We're just going to do some microphone tests for everyone here. Sounds pretty reasonable to begin with. Talking out a good little volume right here and going to the handheld. There we go, coming on, and yeah, sounding pretty good over here for the handheld. Test, test, 1, 2, 1, 2, 3, 4. Handheld, going to the podium right here. Podium seems pretty easily to adjust if needed. And then back to the handheld over here. Handheld, 1, 2, 3, 4. Microphone test, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, I think sounds pretty good.
Someone can stand and talk, and other people can use the mic. But if you
Talk to Brent, see if that's something we can all
no, it's fine. That's what I want to do. Stop. I got it. Go away.
the guy that makes sure the slides are here. Oh, yes, ma'am. Oh. Oh, like right here? No, that's fine. As long as you can click on it, it works. Alright, let's find out. Oh, it's there. Yes, ma'am, that works. What time are you supposed to get? Oh, so 10 o'clock? Yeah, okay. 9:30, 10, 10:30. Yes, ma'am, I see. As long as you don't click on it, it's alright. Kevin Sims, Bratton, Serena. Yes, ma'am. That's yours, correct?
No,
That's not? Okay.
mine's a panel. The one that says panel discussion.
Which one is this one?
This one.
Right here.
Yeah, I already switched it out.
Oh, okay. Well, then you got it. Yeah.
Yeah.
Good. Sweet.
All right, thanks.
You're welcome. No. That works. Mr. Kevin? Okay, sweet. Is it supposed to be like that? Okay. Check 1 2. Sweet.
Yes, yes, this will be the room for, what is it? Press, yeah. I'm gonna knock this down just for a moment. Sorry, everybody. And you have it on thumb drive?
Yes.
Yeah, just go ahead and plug it in if you can.
Kagla first folder.
This one?
That's the one. Yeah.
Perfect. Okay. And what?
Can you
if
save it on the desktop here? Or?
Okay. Is there? No. He's just down. He made some last minute. Yeah. No, we're set up. No, I have everything for 9:30 ready to go. Yeah. Do you have a video on here? You said? Or did I make that up?
Yeah. Keep going down.
Okay. We can test the video later, maybe
Okay,
at
that's fine.
lunch. But I wanted to make sure. Okay, I'll come back to this and test it out.
Yeah.
All
There's
right.
2 slides. So. Yeah.
So I'm gonna just do a quick save as, so it's not going anywhere. Onto just say downloads. Cool, you should be good to go. So you can unplug.
Spit it out.
Yeah, spit it out. This is 9:30, and I'm getting out there here. So this is gonna be the morning session, and I'll check on that video at lunchtime.
All right, everybody. So we're going to go ahead and get started here. Thank you, guys, for joining us for our Precision Medicine Prevention and Early Detection block. So I'm happy to introduce Kevin Sims. Kevin is the Associate Vice President for Precision Medicine at Ochsner. He also happens to be my dyad partner. So we work really, really closely at work together. And Ochsner's under a dyad model. If you don't know what that means, we kind of live and die together. We have the goals. If we succeed, we succeed together. If we fall, we fall together. So we got to have each other's back, which is really good. So all right. Well, with that said, I'll hand it over to Kevin, who's going to be talking to us about population-based hereditary screening. I think this is a really important topic, and the work he's done has been absolutely instrumental in growing not only this program, but really a precision medicine program that's getting international attention across the board. So thank you for all your work.
Don't clap yet. Don't clap yet. Wait, it might could be worse. So Dr. Matrana talks about our dyad partnership, and I kind of say it's like we're work wives, or he's my work wife. So we kind of have that kind of relationship, which works out well. So as he said, I'm the Assistant Vice President for Precision Medicine. I've been in this role for about 5 years. Prior to this, I spent 20 years of my career doing healthcare IT, both Cerner and Epic integrations and oversight, project management office. So my expertise is not in the clinical space. I am probably the least clinically expert person in the room, but my expertise in workflow, process development, integration, and figuring out how to get things in place is what we'll be talking about a little bit today. So a little bit about the outline, just a bit of an introduction to hereditary cancer, problems and goals that we have, a brief look at our genetic wellness assessment and how we've implemented that, our high-risk clinic, a little bit of question and answers, and then we'll have a QR code at the end in case anybody wants to try out the tool for themselves. Okay, so you guys are likely aware of the prevalence of hereditary cancer. More than 1 in 8 cancers may be caused by inheritable genetic changes, and the impact of those changes, everything from adjusting of cancer screenings, possible risk reduction options, efficient cancer treatments, and then helping to also identify at-risk family members to ensure that they are getting the same testing as well, to ensure that, that we understand and they understand what their risks are. And so some of the challenges of hereditary cancer detection. So how do you know if you are a candidate for testing? Cancer at a young age, more than one cancer, a lot of family history, unusually rare, and just as a little bit of a, here we go. Oh, no. Well, you can imagine that this was 2 versions of NCCN guidelines that changed very quickly within a course of a couple of months. And so the purpose of this slide was to just kind of demonstrate that they are changing very quickly. So it's very difficult for providers or patients or really anybody that has a touch with this to understand what those current guidelines are, to understand what your risk factors may be to get you into genetic testing. And so we do a little bit of rewind back to 2023 and where we kind of started this journey. We had 2 genetic counselors in the system. We did not have standards for genetic testing. We did not have discrete results to easily identify patients. And we hoped that patients didn't fall through the cracks for their screening needs. The reality was that patients bounced around from GI to GU, to breast, to derm, to wherever they needed to go, subspecialist by subspecialist, and we really kind of like did not have a lot of coordination for follow-up and tracking. Primary care was also really unable to effectively manage due to lack of expertise, complication. Those visits are like 20 minutes long, so trying to have primary care figure out what all of those things need to happen for a patient in that 20-minute window was really not an opportunity for them to really spend that time to do. And so it largely didn't happen. And so the high-risk patients largely were left to their own management. All of my pictures are like, here we go. So that's the patient that is left to their own management. Okay, so the Angelina effect. So several years ago, Angelina Jolie had identified as having a BRCA, and she had a double mastectomy prophylactically. And so as you can appreciate, the complications with a BRCA, everything from breast cancer to ovarian cancer, melanoma, pancreatic cancer, and others, there's just a lot that goes into understanding what your screening needs may be, not just from the gene, but from the age, the family history, the personal history, and a lot of other various factors. So just because you have a gene doesn't mean that you have the same treatment or same screening needs. It's going to vary based on your own personal factors beyond just your genetics. And so we had some goals. So our goal is to create a hereditary cancer and high-risk program. And this was intended to identify patients who meet criteria for genetic testing, staff up to meet the demand. Those 2 genetic counselors weren't going to be sufficient. Train high-risk providers through the City of Hope course in California, develop standard protocols for high-risk screening needs, and to heavily leverage our electronic medical record for workflows, clinical decision support, and patient tracking, so that we can help to automate both for patients and providers what to do with their high-risk needs. And so currently what we've done is we have a genetic wellness assessment, and we'll talk a little bit more about that. We've staffed up. We now have 10 hereditary cancer genetic counselors who do counseling and testing. We have 6 high-risk providers in the system who will have yearly or bi-yearly visits with referrals to specialists, diagnosis, testing, and follow-up. These are essentially serving as a primary care provider for these patients to a large extent to help them navigate all of their needs. This reduces the burden of specialties, so instead of specialists having those individual visits, those specialists can focus on the surgeries and the more complicated conversations with them, while the high-risk department is taking care of all the kind of the daily needs. We also have a standard genetic panel that we have fully integrated in with both orders and discrete results in our electronic medical record, and we have protocols that are in development, as mentioned, by age, by gene, by sex, by history, et cetera, so that we have a little bit more, an easier way for our high-risk providers to know what to do with those patients when they come in, so they're not having to invent the screening needs for that patient for each time they come in, for each individual unique patient. And then we're also working on building reminders to both patients and providers when the patients are due for screening so that nobody has to remember. So the electronic medical record can be in place to remind that you need a mammogram or your MRI or whatever that screening needs. And if you haven't had it done, the plan is to send reminders to both patients and providers. Okay, bunch of check boxes, all out of order. So our GWA. So it is a hereditary cancer screening tool that aids in the identification of hereditary cancer syndrome and facilitates cancer prevention and early detection for patients at high risk. We use a lot of branching logic. We have about 127 total processes that are organized to minimize patient burden. It's a minimum of about 2 questions, maximum of about 24, and it takes about 10 to 15 minutes to get through. Our goal with this was to get to yes as quickly as possible. So we're not trying to capture the entire patient's family history. We're not trying to integrate that into electronic medical record. We're just trying to get it as quickly as possible for the patient to know if they need it or not, so they can get out of the questionnaire and move on to scheduling an appointment. I don't know if this is going to work. This was a little video that I thought was going to work out well. It didn't. I could push on it. So thank you. That's what I was looking for. Okay, so you can imagine this is like the entirety of the workflow that we have built. This is the Visio version of it, and it has all the various pathways, and the pathways will kind of go different directions based on the answer of the question for the patient. And so instead of having to fill out all of these, this is the mechanism that we have used to streamline it to make it as quick as possible for patients to get through. The video was very compelling, so I'm sorry that you missed that. But so the GWA, so this is a bit of insight into what the patient sees. So we send a MyChart message to patients. We use it's a tool in Epic called Campaigns, so we automate all of this. So the system is just running every day, and it's sending out genetic wellness assessment messages to patients, so they get that in their MyChart message, and they're able to go and fill it out themselves. It is a screening tool. It looks for the major criteria for genetic testing, and if the major criteria are met, then we will let the patient know that they've met criteria, and we'll do that immediately as soon as they get to a yes, and then that allows them to move into the next step of working towards scheduling their appointment directly, real time, in Epic with the providers. What it doesn't do, so it's not 100% sensitive or specific. It's not all of them, and it's also not perfect because patients don't answer the questions correctly. They don't know if it was an ovarian or a stomach or whatever it is, and they'll answer the wrong thing, and then they actually get into the visit, and they don't meet criteria at all. But, you know, we can only do as good as we can do with what the patients know and what they say. However, if they don't, we still do offer them a mechanism to meet with a genetic counselor if they would like to. And we actually get quite a few patients that are just like, I know if I don't, it doesn't matter if I meet criteria or not, I still want to meet with you guys just to kind of understand what's going on and see if I want to get tested anyway. And so what happens after genetic testing? So this is the migration from those patients going from genetics to high risk. And so we coordinate those complex and always evolving multidisciplinary patient care pathways. So we work with the specialists that are in the system. We've actually just recently stood up a group of subspecialists that we will work with to understand what are their specific guidelines for how to screen patients based on their specialty. So between GynOnc and all of the circles that are here, we take that information to develop those pathways, and that's one of the things that we are working on today. Some of the downstream effects of this, obviously, is that it builds awareness around hereditary cancer and prevention. We'll build patient loyalty with this because as patients come in, what we're learning is that if we have genetic testing with those patients, they are much more likely to stay with us because that genetic testing is important to them. And then there's also the market differentiation, and there's significant downstream revenue that comes from these patients as well. And so some of the key takeaways, just recognizing that the hereditary cancer syndrome can improve cancer prevention, detection, and outcomes. Our GWA is a all-in-one screening tool available, and it can be administered as an EPIC questionnaire. Our campaign will automatically push it to patients and allow them to both meet criteria, decide that they want to have a visit with a genetic counselor, schedule that visit with a genetic counselor. So the first contact that we will have with a patient will be at the visit. And so having the tools facilitate everything from identification of patients who may meet criteria, to have the visit allows us to really kind of scale this at a pretty significant pace. And then we're developing those clinical and EPIC support systems. Okay, so before we get to Q&A, I'll put this up here. If anybody is interested in doing it, you should get, I hope this works, you should be able to get directly to the site to be able to go through the questionnaire yourself and see if you might meet criteria. All right.
Meet criteria, you can schedule right.
Just do it, yeah. And if none of that works, then tell Stephanie. Any questions?
Yeah, let's take the genetic blood.
Okay, good. Whew, okay. Very good. Yes, ma'am. If any, like, other institutions, you mean? Mm-hmm. Mm-hmm. Yep. Yeah, exactly. And it's not just for, it's for whether you have an EPIC record or not, whether you've been to Ochsner or not. This is for any patient or any individual that's out there that would want to do it. It goes through, it uses our EPIC tool, our MyChart tool, but this one is the web-facing version, so it allows you to, even if you haven't been a patient before, to complete the questionnaire and then register.
And I think the website is ochsner.org/genetic wellness survey.
I believe you.
I think, yeah, if you Google Ochsner genetic wellness survey, anybody in the world can take it. So you don't have to be an Ochsner patient or any patient in Louisiana.
Okay, yes, ma'am. Mhm. So You wouldn't meet NCCN criteria for it, obviously, but our genetic counselors would have that conversation with you to talk about what other risk factors you may have, and then determine if it's still something that you would want to move forward with. You'll probably have some implications with insurance coverage with that, but the partner that we use for testing does help to reduce that out-of-pocket cost through financial assistance programs. So yes, if there are people that are adopted or don't know about their family history, but are still very curious about their genetics, we would still recommend that they see a genetic counselor. Very good. All right, I'll be here all week. Thanks, everybody.
All right, yeah, this is, the GWA really is game-changing, and Kevin, I couldn't imagine having a better work spouse than you. So, and I do want to recognize Ochsner MD Anderson as the sponsor of this track, of this block. So next, I want to introduce our next speaker, Dr. Melissa Brayton, and she's going to be talking to us about multi-cancer early detection. This is a concept you're going to be hearing more and more about, right? This is the idea of screening for cancer with a blood test. So a liquid colonoscopy, a liquid mammogram, if you will, but not just screening for a few cancers, screening for lots of cancers. And I have no doubt, and I've been wrong with my predictions of the future before, but take it for what it's worth, but I have no doubt that in 10 years, people are not going to be referred for routine screening colonoscopies if you have a normal risk patient. You're not going to be referred for mammograms. You're simply going to go into your annual visit with your doctor and do a blood test like you do for cholesterol or anything else. You're going to do a blood test for cancer. And only if that is positive, then you would go on to more invasive things. So Dr. Brayton is going to discuss this in more detail with us. Dr. Brayton received her PhD from University of Mississippi Medical Center in Jackson. She was at LSU for quite a number of years and has been at Ochsner for several years as well, where she runs our biorepository. In addition to being a traditional biobank, the biorepository is also in charge of running prospective collection studies, blood draw studies, and so on and so forth. And she has a special projects team that operationalizes these studies. I think you have, what, a dozen people or so on the team. And one of the things they do is they operationalize our GRAIL study, our GRAIL studies. We have Eric Fung, who is one of the leaders of GRAIL, who's going to be serving on a panel in a few minutes. And so without further ado, I will hand it over to Melissa, and I hope your slides, they're on there somewhere? Okay, you know where to find them? Okay, all right, thank you.
Thank you. Let's see, let me see if I can get out of here. Okay, thanks, everybody. Thank you, Mark. All right, let me see if I can go to this. Okay, great. All right, I'm Melissa Bratton, and again, I'm at Ochsner Health. I'm the manager of the biorepository there. Really appreciate the opportunity to get up here and talk to you guys about multi-cancer early detection. I'm going to go really fast because I have way too many slides. This is a really big topic, and I want to talk about it and be equitable about talking about several of the platforms that are available for MCED testing. My direct experience, as Mark said, is with GRAIL and their platform, the Gallery platform, but I'm going to try to give you a history of MCED testing and why we're doing it, how we got there, and then some of the major platforms that are being developed with that technology. I don't have any financial disclosures. So why are we even doing MCED testing? Well, here's one of the main reasons. Because about 70% of the cancers out there do not have any primary screening methods for them. And so they are just incidentally discovered, and only 30% of the cancers have screening methodologies: breast, colorectal, cervical, lung, prostate. And so the unmet need here is to find a way to develop screening technologies for the 70% that don't have them. And so MCED tests, which are blood tests basically, where they can detect multiple different types of cancers just using a blood draw, could potentially fill that gap. And so the critical need for better screening methods also includes, another reason to do this is to detect cancers early on. So one of the main problems in oncology is that patients present with late-stage cancer, and those patients are what's driving mortality in cancer, right? So not only are 70% of these patients not able to be screened, but often they don't present until they're late stage because they don't have any symptoms until, like pancreatic cancer patients, they present, they're symptomatic, they're already late stage. So the MCED test offer not only a screening mechanism, but also a potential way to predict or find these cancers in their early stages. I'll also say that right now, it's important to note that the MCED tests are only meant to be complementary to the screening protocols, not to replace them at this point. And I will talk about the importance of that in a moment. So you all probably know this, but I just wanted to drive this point home, and that is that we all know that if you can detect a cancer in its early stages, the patient has a much better outcome. And I'm showing here the ones that, several of these already have screening methods, but obviously the pancreatic doesn't. And so if you can, detect these in the blood in stages 1, 2, even 3, you have a much better outcome of patient survival. Now, let's step back, and I'm just going to give you a real brief overview of how we got here. So most of these platforms utilize cell-free DNA or circulating tumor DNA in the blood as a detection method. And this has been around we've known that circulating tumor DNA has been there since the 40s. But it wasn't really leveraged or found to be associated with cancer per se until the late 70s. And then a group in the 80s and 90s were the first ones to say, okay, we can show there's a direct link between this cancer DNA, tumor DNA, and certain types of cancer. Then a really interesting set of studies in the 2010s showed, and this was just incidental findings of non-invasive prenatal testing studies, that some of these moms that were going in prenatal testing had these weird DNA patterns, and they linked it back to all the moms that had these weird DNA patterns actually had cancers. And so this was the first time that they were able to show that you could detect cancers in asymptomatic patients. So at that point, all the light bulbs went off. Hey, we can leverage this kind of these signals to do screening tests in people who are asymptomatic. So that is when MCED testing really, really kicked off. All right, so the current milieu of MCED design basically uses several different types of biology. Most of them use methylation patterns of this DNA that's found in your blood, different methylation patterns. And the methylation patterns the good thing about them is that they're tissue specific. So most of these platforms will offer tissue specificity of the signals. In other words, when you get a positive signal, they can tell you, okay, you may have cancer, but also it's probably, lung cancer or breast cancer because of the specific methylation patterns in these fragments. And they will also use fragmentomics, which is the size of the different fragments they can detect, copy number alterations, and sometimes they even incorporate proteomics and somatic mutations into the platforms. So as you might imagine, the FDA is highly regulates these platforms, and what they look for when they are in the approval process of each of these are the following. Obviously, they want to know that they are analytically valid. In other words, are the tests reliable and reproducible? And they really want clinical validity, in other words, prospective performance data, so large prospectively enrolled clinical trials. And in those trials, they really look for sensitivity, specificity, positive predictive value. What that is when you get a positive test, do you actually have cancer? because sometimes there are false positives, right? So that's a big issue. And also, it's really important the tests have tissue of origin, so that if you have a positive, the test will tell you breast cancer, ovarian cancer, so that you don't just go to your oncologist and say, well, I have cancer, I don't know where it is, though. And then they're like, well, let's just do some random testing to see where it is. So if you have a breast cancer, they can do a mammogram, that sort of thing, and start. Another thing to look for is the benefit to risk profile. So are the clinical benefits, do they outweigh the risks of, like, say, for example, false positives? So patients who have false positives they're under a lot of stress, anxiety. Does all of that, is that mitigated by all of the good results of the people who actually do get the true false positives and are able to be treated? You have to be really careful when you design your clinical study, what your primary objectives are going to be so that they're met. And then the post-market and real-world evidence data, in other words, ongoing evaluation, long-term evaluation of your data, very important. Okay, so I put this up there because what you'll see, and I'm going to show you some data from the different platforms, is I put this up there just to show you that a lot of these trials, the inclusion criteria is that, you have to be at least 50 years old to participate in most of these trials. And that is because the data has shown that once you hit 50, your chances of getting cancer goes way up, which is really terrifying to someone who's over 50. But it's just the way it is. And so that's why I showed that slide. All right, so I'm going to talk today about three different platforms. As Mark said, the Gallery platform is what I'm most familiar with because I've been working on two studies, Pathfinder 2 and the REACH study at Ochsner. It is also the platform that is the furthest along in FDA approval submission. And Gallery, GRAIL submitted the Gallery test for PMA in the end of January. So it has the most data, published data, and so we'll be talking a little bit about that. And I'll also talk about Guardant's Shield MCD test and the Exact Sciences Cancer Guard test. I'll briefly mention a couple of others. But there are dozens of MCED platforms out there being, tested. So it's not, it's a really wide open field. Okay, first of all, Pathfinder. Pathfinder was the first prospective interventional study that GRAIL put together, and it enrolled 6,600 asymptomatic adults over 50 using the Gallery test alongside standard screening to assess real-world performance. The overall cancer detection rate was about 1%. The positive predictive value was 43%, which means that of those 1% detections, 43% of those subjects actually had cancer after further workups. Of those, 88% of them, the CSO accuracy was 88%. So it's correct tissue prediction. The specificity was 99.5%, so a low false positive rate. That led to the follow-up study, the Pathfinder 2 study, which Ochsner participated as a site. That was a much larger study, and it evaluated the test performance at a larger scale. The study enrolled over 35,000 participants across the country. The specificity was 99.6%, which was 0.4% false positive rate. Positive predictive value was over 60%, and the CSO accuracy was over 90%. And also GRAIL reported the MCED testing increased to screen-detected cancers nearly 7-fold over AB screening and approximately 3-fold over ABC screening, and this highlights MCED's complementary value for cancers without established early detection. That data was released only in October of 2025. So these are all very new data. We will obviously be getting more as the next year. I just want to show also the Pathfinder 2 sensitivity data. So these are and this is important to note that the tests are really trying to pick up early stage cancers. And so you can see that the stage 1 and stage 2 and stage 3 detection levels, they go up as you get higher stage, right? Later stage. And that makes sense because once the tumors get larger, they're going to be spitting out more DNA, and it'll be easier to pick them up. But it's also important to note that you do get a nice level of detection in stage 1, 2, and 3 in these tests. And so I just wanted to put that on there. The 12 cancers that account for the 2/3 of the deaths are on the right-hand side, and that is shown in the detection of those are shown in the dark blue boxes there. You may have all heard of some recent data that was published about GRAIL's NHS Gallery randomized trial in the UK. That was a very large study, and around 140,000 subjects were screened and enrolled into usual care versus usual care plus gallery testing. They just started publishing data from that or giving us some data from that. The primary endpoint, the formal primary endpoint was not met, highlighting the difficulty of demonstrating stage shift within a single trial. Stage shift meaning does adding the gallery test or these MCED tests into a population on top of standard of care shift the diagnosis of stage 3 or 4 cancers to the left, to where now you see more stage 1 and 2 cancers. Do you catch them before they get to stage 3 and 4? However, so the primary endpoint of that study was that they were going to reduce 3 and 4 cancers. However, the study did show that over 20% year-on-year reduction in stage 4 diagnoses for the 12 lethal cancers. So there was a reduction in stage 4. And so this, the observed stage shift suggests a clinically meaningful impact. And so more time needs to elapse before, they can show us more data on that, but it is promising, I think. And so we'll just see how that plays out. And we're still waiting on Pathfinder data, which we'll get hopefully soon. And I think that's exciting to wait for. Okay. Next, we'll talk about Guardant Shield, so Guardant is working on its own multi-cancer early detection test. So they have also developed, so it's in development, and they're working on a test so the Gallery test can find over 50 different types of cancer, 50. This particular test it's in development, and they have done a blinded case control study on 10 different solid tumor types with this platform. It works by identifying epigenomic signatures in plasma, and also detects cancer signal origin. The cohort that The cohort that they enrolled, it was 962 participants, 472 cancer cases, 442 non-cancer controls, so it was a controlled study. They knew who had cancer and who didn't. And then you see the median age and the females versus males. So the results of this case control study showed a strong specificity, so 98.6, and an overall sensitivity of about 60%, CSO accuracy 92%, and stage 3 and 4 sensitivity was 81%. So as you go up to in the later stages, you will see an increased sensitivity, and that's just kind of across the board, and that's shown below in the bars below. So over on the right-hand side, I'm showing you some of the top performers. So each cancer subtype is going to perform differently in the test. And so what you see here is that prostate, and this is all of the different platforms. I didn't show you that with Gallery, but all of the platforms have these differences. So prostate, 21% overall, esophageal stomach, 96% overall specificity. So some of the more aggressive cancers do better as far as being detected with these tests. versus some of the more indolent cancers like breast and prostate. So takeaways, Garden Shield, clinical implications and path forward. The study exceeded specificity target, 98.6 was observed when the threshold was 98%, accurate signal of origin, 92% accuracy. They do have a CRC, an FDA-approved CRC test already, and so perhaps they can include that with this test to make a single blood draw that may amplify the clinical value of that, that test if they put them together. So they're now undergoing, I think, a prospective validation, and the next step would be a large prospective study to move forward toward FDA approval. Next, Exact Sciences. I need to move faster. So Exact Sciences has their own test called Cancer Guard, a multi-analyte blood test for broad spectrum cancer detection. They have, I'm going to show you a little bit of data from an ASCEND, from a ASCEND trial, which again is a case controls trial, prospective multi-cancer study, and the difference in the Cancer Guard test from the others is that they also use proteomics in their test in addition to DNA. So it's got two different types of sample analytes. And so they are building this study on the background of a retrospective case control study that they had. The biomarker strategy, again, single classifier combines methylation and protein signals with machine learning, and they, here we go. The cohort structure, 6,000 prospectively collected samples. So they had 1,400 cancer cases, almost 5,000 non-cancer controls over 21 different tumor sites. Here's the training control, the independent test control. Here are the results. So the overall sensitivity was 49.9%. Late stage detection was higher. Early stage sensitivity, 23.6%. Again, it's lower in the early stages, and goes higher in the late stages. Specificity, 99.0%. And I think I have on the left side the stages broke it down. Okay, here I have a table showing kind of a comparison of all of them. And again, this should be taken kind of with a grain of salt because you can't really compare studies to each other directly, but just to have them sort of, all of the different platforms on one thing, kind of wanted to show that side by side. And I put in the SHIELD study, the CRC FDA-approved platform on there just, as a comparator, even though it's not an MCED test. I won't go through that, but it's just, FYI, this kind of thing. Okay, other MCED platforms. Briefly, want to discuss some other MCED platforms. Interestingly, I just want to talk very briefly about CancerSeek because it has an interesting story. It's not really a current MCED platform, but it's kind of the original platform that all the others are based on. And some guys some people from Hopkins put this together in 2018, and it eventually turned into the platform used by Exact. And so, it was kind of like the platform of the design that everybody else kind of piggybacked on. Then we have one called the Carcimum platform. TrueCheck's got a platform. A lot of people have platforms, but they're in the very, beginning stages of development. Okay, important stuff. Current limitations, open questions. Right now, none of these studies have proven mortality benefit, okay? But we just need more time. I mean, the data is still very young, and so we'll have to just observe longitudinal data, see how these patients do long-term to get really good mortality benefit. There is limited early-stage sensitivity, so, and that's, when you're designing these tests, you want to get good sensitivity, but you also want to limit false positives, and so that is going to limit your early stage sensitivity. But, so, some of these early stage cancers will be missed, but the third, stage 2 and 3, when you get up to like stage 3, you start getting really good sensitivity. There is a risk of overdiagnosis. So MCEDs may detect indolent cancers, and that would never cause symptoms and might lead to treatments that are unnecessary and provide potential harm to patients. There are false positives, and that would lead to diagnostic cascades, which cost money to hospitals and patients. Health equity concerns. Right now, none of these tests are FDA approved. None of them are approved by insurance. They cost a lot of money, hundreds of dollars. There are people that can't afford that, and those people are often marginalized as it is, so there are equity concerns. Risk of false assurance. This is a really big one, okay? People who have a negative result often feel like they don't have to get their screenings. And I can speak to this personally because I enrolled both my parents into this REACH study. They both got negative results, and my mom's like, whoop, I don't have to get that colonoscopy. After I told her and counseled her over and over again, okay? And I'm like, absolutely not. That is not what that means. So a lot of work's gonna have to go into counseling patients on following up with their regular screenings. What's the road ahead? A Medicare coverage pathway. So the good news is that in February, the Nancy Gardner Sewell Act was signed into law, which established a Medicare coverage pathway for FDA-approved MCED tests, which should start covering, Medicare should start covering these tests in 2028, and hopefully that will lead to full insurance coverage in the future. The FDA is developing a Class 3 pre-market approval pathway for MCED tests. The NCI Vanguard study is a really large study which launched last year to evaluate MCED feasibility and diverse average risk adults. Mortality endpoint trials. Again, we need to know if this is going to affect mortality of patients. And then next-gen assays, it's just happening so quickly, including multi-omic integration, AI-driven. AI is going to change a lot of things, as we all know from this trial, from this talk. Okay. Wow, I'm way past. Okay, that's it. Thank you.
Any questions?
Okay, great.
All right, this is a fascinating era that is a topic that is moving very, very, very quickly. And our next speaker is also going to tell us about a topic that's moving very, very quickly, and that is pharmacogenomics. So Serena Mitali helps us run our pharmacogenomics program at Ochsner Health, and she's going to give us an update of where things stand in this really interesting field. So.
Perfect. Let me just go ahead and pull up my slides, and I'm excited to talk about pharmacogenomics today. Are they on here? Okay. Am I 10:30? Yeah, none of these are mine. Sure. Yeah, so these are all the ones that are currently pulled up. None of these are mine. Yeah. Oh, you just had too many up here. I couldn't find me. I thought I would be prioritized. It's my turn. No, it's okay. All right, and then we'll just start slideshow. Okay. I promise I'm a millennial and I know how to use technology, so. That being said, hello everyone. It's an honor to be back here at CAGLA talking about pharmacogenomics testing here at Ochsner. And today I really wanted to focus on recent updates in the space of DPYD testing and how these updates are really moving this towards the standard of care, what our journey has looked like at Ochsner, and how if you're an institution and you want to start implementing DPYD testing, how to best go about doing that. So I have no financial disclosures to report, and I want to go ahead and start us off with a story, as we like to do at Ochsner. So this was a patient who was not treated here at Ochsner. They were transferred to us from an outside institution, and they presented with severe toxicity syndromes, likely from their FLOT chemotherapy. So they came to us with tongue swelling, mouth sores, severe dysphasias, cytopenias, and they actually did require emergent intubation upon presentation. That patient did not have a DPYD or pharmacogenomics test completed. The team recognized that these symptoms were likely potentially due to this patient having a DPD deficiency, and so they immediately put in an order for our PGX test. So unfortunately, this patient did not make it, and when the results of the test came back, they did show that this patient was a poor metabolizer. And I like to start with this case because it really highlights what it can look like in practice if testing is not done, and how severe the toxicities of these medications can be when patients don't have DPD function. So a little bit of background on DPD and fluoropyrimidines. So DPYD is the gene that codes for the DPD enzyme. This enzyme is responsible for 80% of the breakdown of our fluoropyrimidine medications. So this is our capecitabine or Xeloda, as well as 5-FU. As we know, these are key mainstay therapies in the treatments of multiple types of solid cancers, particularly with colorectal. And we see many patients, up to 2 million of these patients treated per year. With DPYD intermediate metabolism, we expect these patients are only going to have about 30 to 70% of the function of the DPD enzyme. So if you're removing the primary driver for breaking down these medications, these patients are going to have really high levels of these medications in their blood after they take them, and this is going to lead to severe toxicities. So how often do we actually see this on a global population? We see typically around 3 to 6% of patients we expect to be intermediate metabolizers. And when we think about that from a clinician facing, that is around about 1 in every 25 patients you will see is likely to have this mutation. For the patient in our case who is a poor metabolizer, that is much more rare. We usually see that in only 0.1 to 0.5% of patients, but we saw it, and it is out there, and it does happen. So I want to talk a lot today about some key milestones in the adoption of DPYD testing, and I put together this slide to really highlight that here in the US, we are actually very behind globally compared to what other countries are doing. So starting back to 2013 and 2017, this is when we first had some of our clinical guidelines published, and these give us insights onto how can we give patients appropriate doses of these medications so that they don't experience these severe toxicities. So our key guideline that we look to is the CPIC. This is the Clinical Pharmaco-Implementation Consortium. They are an international group that reviews all of the different data pertaining to different gene-drug pairs, and they are the ones who will release dose guidance adjustments based on genetic results. And this is when some other countries, such as Switzerland, started to have voluntary testing. But really, as we can see in 2020, this is when our European colleagues start putting into their legislation that we need to be screening patients for this toxicity. So in 2020, both the EMA as well as England put out these safety updates, and they are mandating testing prior to giving patients these therapies. So we do not have mandated testing in the US through either our NCCN guidelines. But last year, in October of 2025, the FDA did put a black box warning on capecitabine or Xeloda that states that patients need to be tested unless they need to be emergently started on chemotherapy. So this has been a huge landmark in terms of, landmark or milestone in terms of having that national regulation piece for getting our patients tested. Now, I will when we talk about our journey, we'll say how we started back in 2021, kind of got the ball rolling before this happened. But now for everyone else out there, knowing that it is at the level of a black box warning, it's going to really help us to drive reimbursement. It's going to really help to convince your oncologists and everyone in your institution that we need to be doing this for patient safety. So looking at some of the lessons that we have learned by implementing DPYD testing here at Ochsner, I really want to talk about the key factors to consider when you're implementing a new service clinically, specifically for us, DPYD, but we can use this in other areas as well. The first thing you're going to need is support from your leadership, because you're going to need a lot of different resources, different people to build tools. So if you don't have that key support from your organization, very likely your implementation is not going to be successful. The next thing we'll talk about is testing reimbursement, since one of the first questions I always get when I talk about my test is this going to be covered for my patient and how much is it going to cost them? Then we'll talk a little bit about reference lab selection, because one size does not fit all. There's a lot of different labs out there. It's really important to understand some basics of how does this testing work and how can I pick what's going to be best for my institution and my patients. Then we'll talk a lot about how, once we have this information, how do we use it effectively to get it to our providers at the point of care so they know how to treat patients. And then lastly, staff education. As we all know, we're in an interdisciplinary world, so everyone who's going to be using your new service should have that level of education so we can get it to our patients. So brief history, as I mentioned, we did start our journey with implementing DPYD testing back in 2021, and we started with that key shareholder support piece. So how we were able to do this is that we conducted a pilot study, and we looked at patients who had toxicities when taking fluoropyrimidines. We got those patients tested for DPD, and then we reported those outcomes and said, hey, we could have avoided all these had we known these patients were intermediate metabolizers and had dose reduced them. And I apologize, I usually have the slide up, but I missed it. But we tested 106 patients who had severe adverse effects. Of those patients, 11 of them were intermediate metabolizers. And of those 11, 5 patients were admitted due to their toxicities. And from those 5 cases, they had a total of 83 inpatient days, which comes down to about 16.6 days inpatient on average per patient who's an intermediate metabolizer. So knowing, if we had known that previously and gave them a dose reduction, we likely could save about 16.6 inpatient days per patient, which has a huge cost savings implication as well. And the other thing I like to point out about this slide, this we actually took from our publication outlining our implementation journey, but I think it does a really good job of highlighting all of the different steps that needed to happen and how long and how much planning and interdisciplinary work went into getting our program to where it is today. So you can see here the project management, starting with the readiness assessment, what are we going to need for success, putting together the pilot group, getting the key stakeholder input, and then from there, how do we want to do this? What tools are we going to use? Who needs to be educated? How are we going to educate them? And so we'll talk through all of these different points, but I really like to show just how it took us the span of several years and having all of these steps come together at once. So moving into testing reimbursement, have to give a huge shout out to this organization, NCAGLA, because with these grassroots organizations, we're able to do advocacy efforts to get more coverage for our patients. So this bill here, the LA Senate Bill 84, this required health insurance companies within Louisiana to cover genetic testing for patients who have an oncology diagnosis. And with this, we really rarely, if ever, see reimbursement issues for our oncology patients for DPYD testing. It's essentially a non-issue. So even outside of oncology, all of our patients who have a traditional Medicare, Medicaid, or TRICARE plan will have a $0 out-of-pocket cost with our genetic test that we use. And in the case for patients who have a commercial payer who may have a very high deductible or a high cost, our lab will actually pre-qualify those patients into a financial assistance program. The max out-of-pocket a patient would have to pay for the test is $350, but the average cost that we've seen is much, much lower in practice. So we're really proud of all the work we've done in this space. Thank you. And then, just some other factors, like what if I'm not in the state of Louisiana? What if I still have a lot of other hurdles? How can I try and get these payers to cover this important testing? So one of the biggest things we found is having that documentation that the test is medically necessary. So for example, in our test, when providers go to place the order, they have an option and it will say, there's a medication that has an FDA label indication that testing is necessary prior to starting the patient on therapy. So that's a really good way to show payers, we have the FDA label, this needs to be done for our patients. Another big thing is focusing on genes that have recommendations from our guidelines. So our CPIC level A and B, that's going to greatly increase the likelihood that payers will provide coverage. And then utilizing a multi-gene panel over an individual gene test. So I pulled these numbers from a study taken out of the University of Florida, looking at reimbursement rates for both single gene as well as multi-gene panels throughout all of the different payers since they have their own laboratory. And they found that overall, 74% of the multi-gene panels were covered across all payers versus only 43% for a single gene panel. So this is showing the more things that you can prove patient benefit on, the higher chance that the insurance is going to provide that coverage. And then I want to highlight this here. This is coming from our clinical guidelines, our CPIC. This isn't 100% up to date, but we have over 28 guidelines. These guidelines are updated as new literature is published. And I've bolded some of the key ones here. I hope you can read, but there are other gene drug pairs within the field of oncology that we can get from panel testing. There are a lot of different supportive care meds that patients are likely to use, including antidepressants, Zofran, pain medications such as codeine, tramadol, NSAIDs. So getting one panel can not only help guide chemotherapy, but a lot of other supportive care medications that patients may be taking or will be taking in the future. So the next question, what actually makes a good DPYD test? If I'm not familiar with pharmacogenomics or genetic testing, how do I know which test to pick and what factors are important? So generally speaking, most PGX tests are going to fall into one of two categories. The first is a genotype-based test, and the second is a sequencing test. Again, this is generalizing it down a little, but a genotype test is only designed to look for a specific SNP or genetic change at a specific portion of the DNA. So really with a genotype test, it's only going to find things that it is programmed to look for, versus with sequencing, it's going to be reading the entire DNA sequence. So you will find all of the potential variants that may exist by using a sequencing test. So applying this to a clinical example, let's say you have a patient and their genetic result is they're a star 1 / a star HAPB3. Well, if you have a genotype test that would only be looking for a star 2A variant and a star 13 variant, the patient receiving that test, it would come back as a star 1 * 1. And star 1 is kind of tricky because it reads as normal metabolism, but it also reads as I didn't find the variant that I was looking for, so I'm reporting it as normal. Versus a sequencing test would be able to correctly read this and call the patient an intermediate metabolizer. So kind of a high-level comparison of genotyping versus sequencing, what should we choose and why? There are really pros and cons to both methods. So as we just discussed with genotyping, it's really important to know what are the variants that we need to be detecting for and making sure that the test you pick is looking for those key variants. Versus with sequencing, you're not going to run into that issue. You're going to see all of the DNA. Genotyping is generally much more cost-effective than sequencing. The cost of sequencing has come down recently, but generally speaking, most genotype tests are going to be in that $200 to $600 range as an out-of-pocket cash price, versus sequencing is significantly higher. Genotype tests also are able to come back much more quickly. It takes a lot more time to sequence the entire DNA, versus a genotype test is typically somewhere between a week to 2 weeks for a turnaround time. We already talked about coverage, limitations talked about with genotyping, but a potential limitation of sequencing is that you can get a variant reported back and we don't have information as to how that genetic variant actually impacts patient care or management of that drugs. So you have this information, but you don't really know what to do with it. It can be really useful in terms of research, so having a lot of people do sequencing, put that information together, identify what that change does, but for just direct point of care, it's not going to be as valuable. So what are the important alleles to test? I went ahead and pulled this from AMP, or our Association for Molecular Pathology group, and what they do is they look at all of the different variants that have been identified for a particular gene, and they look at how often we actually see this variant in the general population and what is the function of that genetic change. So anything that is within the tier 1 is present in at least an appreciable amount of population, and we know that it has an impact, a strong impact on the enzyme function. So as you can see here, we do have 7 tier 1 alleles for DPYD, and for these are ones you would definitely want to have included on your genotype-based test. If you are missing these, you are missing key potential variants of this gene. They do also list a tier 2, so these are things that are optional. We don't see them as appreciably. We're maybe not as sure on their function, but we've seen them enough to think that it is significant to report for research, and we may get more information on these variants down the line. Just a side note, we have these tier 1 recommendations for other genes as well outside of DPYD. So if you are looking into a multi-gene panel, this is a great resource to check those labs and make sure that they are looking at these variants. So other advantages of the multi-gene panel, already kind of went over this in our CPIC slide, but there are a lot of other oncology-related pharmacogenomic testing indications. So with UGT1A1, there is recommendations for irinotecan, for poor metabolizers, as well as sacituzumab and belinostat. With our TPMTs and NUD-T15s, there's recommendations with thiopurines, and then with CYP2D6 and tamoxifen. I know I briefly mentioned the SSRIs, other supportive care medications, but what I didn't mention is that we see variations in our 2 enzymes, CYP2C19 and CYP2D6, very commonly on a population base. So around 30 to 42% of patients that we test are going to have a significant result in these genes that can impact response to these medications. So how do we actually take the pharmacogenomics testing and bring it to the point of care? I really like this quote, "Data without workflow is useless." Something that we like to say is if you're a lab and you're not providing discrete data into our electronic medical records so that we can provide clinical decision supports, we're not even really going to consider using you because we can't get it to the providers. So there's a lot of different ways that you can design clinical decision alerts and tailor them to your institution and what your providers need. I'll go over some of the ones that we have for DPYD on the next slide, but generally speaking, our goal is to get the right information to the right person at the right time. And so we try to only utilize hard stop alerts for those interactions that are significant. So the patient will have a severe toxicity if given a full dose. They need to be dose adjusted. Or the patient is very unlikely to respond to therapy and have a bad outcome from that, so you need to use something else. We also do use inline alerts. So there are cases where there isn't a specific dose recommendation change. However, there is still a chance that that patient may not respond as well or have a side effect, and so we still want our providers to have that information at the time of prescribing. And then how do we actually embed our testing within our oncology workflows? So this is an overview of what we do at Ochsner for DPYD as well as some of our other PGX results. So what's been really game-changing for us is we're able to embed our PGX order with all of the other pre-cycle laboratories in our treatment plans. So really what this allows for is earlier testing to ensure that the patient is getting tested and that the results are coming back in time prior to that patient needing to start their chemotherapy. So if they are an intermediate or poor metabolizer, we can make that dose adjustment in time. We also have an alert if somehow a patient was trying to be started on therapy and they didn't have a PGX test. They would get a hard stop, say, hey, don't do this, you need to order the PGX test. And then, as I mentioned, if patients do come back with a variant, we will provide the exact dose recommendations at the point of the patient receiving the medication. And then I kind of already talked about how we distinguish between significant and critical alerts, but I think it's important to note we have a lot of them because we do full panel-based testing, and there are a lot of different possible medication interactions. We have 92 critical and 191 significant. And another reason that this is important is that if you're doing a multi-gene test, let's say you're an oncologist, you want to know about DPYD, you're getting all of this other information. You may not be using it at the point of care. However, let's say that patient goes on to have a stroke down the line. If they have a significant result in CYP2C19, our clinical decision alert will make it so that provider who's taking care of the patient, they didn't even have to know the patient had the PGX test done, but they're still going to get that alert to avoid that therapy that wouldn't work well in their patient. So it's really good in terms of liability. You know, we're concerned if we have this information, we don't know what to do with it. Does that make us liable for this patient's course? And we're able to solve that with our clinical decision support. So moving into staff education and pharmacy. So I always like the pharma and the pharmacogenomics. Yes, we are genomics, but we are looking specifically at medication adjustments, and that is really the bread and butter of pharmacy. So the roles of pharmacists, we are able to interpret results. We're able to recommend testing to select patient populations because we know what the enzymes are to test, and we know the medications and how they're broken down by each of these enzymes. So within Ochsner, pharmacists play a few different roles in terms of pharmacogenomics. So all of our pharmacists receive annual competency training for pharmacogenomics. This is so that they're able to make recommendations based on CDS alerts and answer questions. For more of our clinical pharmacists embedded in clinic, specifically oncology pharmacists, we had all of them complete the pharmacogenomics certification course through the American Society of Health System Pharmacy Group, so they are able to make additional recommendations, complete consults, and use pharmacogenomics in their routine care for patients. And then our PGX specialists, like myself and my partner, if there are additional questions beyond the role of the clinical pharmacist or a provider needs assistance, they're able to put in an e-consult to us. And then we're also very deeply enveloped in program development. How do we ensure that we're keeping things up to date? How do we ensure our CDS alerts are working properly, et cetera? And then my last slide is just with program governance and sustainability. So as we know, the field of genomics is moving fast and will only continue to move faster. So we have a large interdisciplinary group and a subcommittee, and we go through new data and literature as it becomes available so that we can update our alerts, or if there are new variants that we need to include, reach out to the lab to get them included. And so we have a really large team that works to sustain our pharmacogenomics program. And then, as I mentioned, we have our specialty pharmacists. So this hotline number we have available both to patients and providers. So that's a very useful tool in patient education as well as supporting our providers. And then just want to end it by bringing it back to our patient case. This was not by chance, this was preventable. If we don't accept as a field, as pharmacy, as clinicians, not checking renal function to ensure a medication is given correctly. Why shouldn't we be checking for genomic mutations when we know they can lead to fatal toxicities? And now that we have that in the FDA, this is going to be moving towards more of a standard of care across the nation. And honestly, if you do not currently do this, you should be actively building it because it is not going anywhere and it is just going to continue to grow. Okay, that's all I have for y'all. Thank you so much, and I'm happy to answer any questions you have.
I'll just make a quick comment. At our last CAGLA meeting, we had Karen Merrick as a keynote speaker. And Karen is one of the leaders of the DPWD advocates, and she lost her mom because this testing wasn't done. Now that we have this black box warning, if you don't test and you give this chemotherapy, it is malpractice.
Yeah.
And the lawyers have figured this out. And I'm getting calls fairly regularly from malpractice attorneys across the country who are saying, can you come serve as an expert witness on this case? Now, Ochsner really discourages us from testifying against colleagues in malpractice cases. So I can just say, sorry, I can't do that. But these attorneys are taking on these cases this is, you know, last year was different.
Yeah.
This year is.
Yeah, last year we had our advocates, you know, saying, hey, we really need to have this testing done. My family is dying, and now we have, okay, the FDA finally said it's malpractice.
Yes, and then, exactly, and then
Yeah.
the attorneys are saying, we're gonna sue you. So, any other questions? Any other comments or questions? So, all right.
All right, thank you.
All right, thank you. That's, again, incredibly impactful, incredibly practice-changing. And now we're going to shift gears a little bit. We're going to go to our panel discussion, and I'd like to introduce our moderator, Dr. Rini E.L. Wanibi. And she is with LSU. She's a faculty member with LSU, and she's also with the Louisiana Cancer Prevention and Control Group. She is an expert on preventing cancer, and I think she's going to introduce our panelists, but I think we have some really interesting discussions ahead. So thank you.
All right, thank you for that introduction. I don't quite know if I'm an expert on preventing cancer, but thank you all for sticking around. I wanted this next section to be a little bit more lively and a little bit more interactive. So I'm going to invite my panelists to come on the come to the front. I'll introduce them in a little bit, but well, I guess I'll introduce myself first. My name is Rini Elouinibi. I'm an assistant professor in epidemiology and population health at LSU Health New Orleans. I'm also the director of the Screen Up initiative, and I'll be moderating this session. All right, so when we hear the term preventive medicine, it's often framed around treatment. We typically think of genomics, targeted therapies, personalized oncology care. These services are incredibly important, as we've heard this morning, but they occur relatively late in the disease trajectory after cancer has already been developed. Precision prevention shifts that focus earlier. Instead of asking how we tailor treatment to a tumor, we ask how we identify risk sooner, detect the disease earlier, or prevent cancer altogether. This approach draws on several sources of information, including risk data, screening technologies, and health system strategies that allow earlier intervention. Many cancers are either preventable or highly detectable through screening. Yet across the United States, and particularly in states like Louisiana, we continue to see disparities in who receives screening, who receives timely follow-up after abnormal tests, and who ultimately benefits from early detection. So the challenge is not only about developing better technologies, it's also ensuring that they reach the populations most at risk. That challenge becomes clear when we look at several cancers where prevention and early detection are already possible. Each is either largely preventable or highly detectable at early stages, yet screening, uptake, and outcomes remain uneven. Cervical, colorectal, and lung cancers illustrate key opportunities for prevention and early detection in Louisiana. Cervical cancer is highly preventable through HPV vaccination and screening, yet disparities exist, particularly among Black women. Colorectal cancer provides another important opportunity, as screening can both detect cancer early and prevent disease through removal of precancerous polyps. Lung cancer remains the leading cause of death in Louisiana, with an incidence rates of about 60 per 100,000 people and mortality around 40 per 100,000 people. Across these cancers, we see a consistent pattern. Effective screening and prevention strategies exist, but disparities in access, uptake, and follow-up continue to shape outcomes. Across these, this brings us to how we think about precision prevention from a systems perspective. At the center is the goal: identifying cancer risk earlier, detecting disease sooner, and ultimately reducing cancer mortality. Achieving that requires alignment across three components: The first is risk identification. This includes genetic risk, but also behavioral, social, structural, and environmental factors. From an epidemiological perspective, risk is rarely determined by biology alone. Tobacco exposure, environmental conditions, and broader social determinants all influence cancer risk across populations. The second is screening technologies. Advances in imaging, AI, molecular diagnostics, and emerging blood-based detection tools are expanding our ability to detect cancer early, sometimes even before symptoms develop. But even the most advanced technologies cannot improve outcomes if people cannot access them. This leads to the third component, implementation systems. This includes ensuring access to screening, building trust and engagement in communities, providing patient navigation, and maintaining continuity of care after an abnormal result. Precision prevention succeeds when all these elements are aligned. When they are, we not only detect cancer earlier, but also begin to reduce disparities that continue to shape outcomes. So with that context, today's discussion will focus on innovations in early detection, the role of risk-based screening approaches, and the implementation strategies that expand access to screening and follow-up care. Importantly, we will also consider how these approaches can help reduce cancer disparities. As detection technologies and prevention strategies continue to evolve, the key question becomes how we translate those advances into approaches that are scalable, equitable, and capable of improving population-level outcome. With that framing, I'd like to introduce our panel. Dr. Michael Celestine is an assistant professor at Louisiana Health New Orleans and is also the director of the Tobacco Control Center. All right, his work, Tobacco Control Initiative, I'm sorry. His work really grounds this conversation in the reality that prevention and early detection don't happen in a vacuum. They're shaped by behavior, access, and the systems people navigate every day. Next, Dr. Eric Fung from GRAIL, where he leads clinical development. Dr. Fung is working at the leading edge of multi-cancer early detection, helping to bring blood-based screening into clinical practice and thinking through what it takes to do that in a way that's both evidence-based and scalable. And finally, Dr. Vijay Kumar from Ochsner Health, where he leads research in radiology. His work focuses on how imaging and increasingly AI can help us move towards more precise risk-based screening and catch cancers earlier when we have the best chance to intervene. Dr. Connie Arnold is not able to join us today, but I left her up there. So thank you, and please help me welcome the panel. Okay, so I'm excited to dive right in, and as I said, I do want this to be a little interactive. So I'll save some time at the end for some questions. So to help ground us, I'll start with a quick round. I'll ask each panelist to briefly respond. When you hear the phrase precision prevention or precision early detection, what does that mean in the context of your work?
Do you hear me? Precision medicine, we all think it's mainly genomic medicine, but precision medicine is a lot more than genomic medicine. It should be very holistic and comprehensive, and it should start prevention population.
So I think that the anchor of precision medicine is really data, and we think about, to your point, large sets of data, and we have opportunities as we continue to progress our technologies to integrate those data. And we'll talk during this panel a little bit about the inputs that allow us to do this in a really equitable way, but also in a compliant way, safeguarding people's privacy. But then also being able to develop novel approaches to, for example, in our field, screening individuals in a much more personal way than we do in kind of a one-size-fits-all approach.
I agree with those statements, and just to add, we have all the data in most situations. The problem is we don't put it all together and create the profiles that might help us make decisions about what treatments are the right treatments, when those treatments need to be provided, and how those treatments need to be provided to patients to help maximize the health outcomes that we're trying to see. Most of us are coming from different backgrounds, living in different places, have different, determinants in our lives, and we need to understand that as clinicians and make this a shared decision-making process. We have the data. We just need to do better at putting it all together and creating these profiles.
Yeah, thank you. And again, that just shows how multi-dimensional this space is. The next question I have, and Dr. Bratton, you brought it up in your presentation, how do we balance innovation with access so that new screening tools don't unintentionally widen disparities?
My personal thought to that question was we have to make them one and the same. You can't have access without that innovation, and you can't have that innovation without making sure it's accessible to people who don't normally get it. I work with different health systems and health centers around the state, and everybody doesn't have the same resources, and they have different priorities that they have to look at. So one of the things that I really thought about was we need to start, I think, pairing hospitals that have the resources with hospitals that don't, or health centers that don't, so that those are hospitals that don't, or health systems that don't, are aware of what's out there and aware of the possibilities that they can tap into. A lot of times people are just busy and doing their work. So I think those types of relationships and connections may help shape how we move innovation into real-world settings, especially those who are working with people who have different health outcomes than we anticipate.
If we believe that data is at the core of our ability to innovate, we have to have two components. One is data in and data out. And Dr. Hill, yesterday's session on AI, really talked about the power of AI, but AI tools all depend on the data that comes in. So as we innovate and we leverage, for example, large data sets and artificial intelligence, machine learning tools, we have to make sure that we account for the right types of inputs. And so, for example, when we look about development of novel MSED tests or other types of screening approaches, we have to make sure that there's representation across a broad swath of the population, so that we train those models appropriately. And then the data out is that we need to ensure that as we study the performance of these tests, give the opportunity to deploy these tests, that those tests are offered to, again, a broad swath of the population. And so we're really deeply privileged to work with Dr. Bratton and Dr. Matrana on the REACH study here, which is a study intended to examine MSED testing in the Medicare beneficiary population, which, for two reasons, particularly here in New Orleans, it's, of course, we understand the demographic dynamics in New Orleans, and also the Medicare beneficiary population is one that is highly at risk for cancer. And we've also worked on, for example, a study in the Veterans Administration hospital setting, because again, that is another set of individuals that have a very unique set of demographics. And so as we think about how we understand these technologies, to the point that was made earlier, it's also about implementation. And as we do these studies in this setting, we can also understand how best to deploy and implement these programs.
I think today, from all the presentations and what you both said, the focus should be on implementation science in addition to lab science and when an abnormal test is there, are they following it up with appropriate intervention? So the implementation science, for example, we can use AI to help us. We can use telemedicine. We can use wearables. Everybody has a cell phone nowadays, and we should leverage those easily accessible technologies to improve our implementation.
Thank you. And yeah, this tension between innovation and equity is going to keep coming up over and over again. Dr. Matrana, do you want to talk about the REACH study a little bit in Louisiana?
Yeah, sure. So, as we alluded to, you know, as Dr. Braden went through, GRAIL has this MCED test, Gallery, right? It's a blood test for 50 different cancers. It is not covered by insurance, but if today you want to get it, you can pay us $800 at Ochsner, and we'll draw your blood test and run the test. Most of our patients don't have $800 in expendable cash to get this test. And so we know, we looked at the data, right? The age range where cancer is the most prevalent is going to be at 50 and above. And so by doing research, by doing this through a research trial, we've been able to enroll nearly 2,000 patients at no cost, right? At no cost, because this is covered through Medicare on the study. And so then we identify it, basically it's open to any patient with Medicare 50 or above who hasn't had cancer in the last 3 years and who's not undergoing a active workup for cancer. So it's a very broad study. But by doing a research partnership, now we've made this available, and we're just getting started with this. I mean, we plan to enroll a lot more patients on this, right? We enrolled 2,000 so far. But we've made this available literally to thousands of people at no cost. We did the same with Pathfinder. We enrolled just under 2,000, or maybe just over 2,000 a little over 2,000 on Pathfinder again. So this is 4,000 people that got an $800 test at no cost because we opened some research studies. And so I think, you know, there's a lot of different ways of getting access to patients, but research is a big one. And the research and the REACH study, I think, is a perfect example of that.
Thanks for that background. And I want to talk a little bit more about risk behavior and real-world uptake. Dr. Celestine, tobacco use remains a leading risk factor for lung cancer, and smoking history drives eligibility for screening. What behavioral or structural barriers most limit lung cancer screening uptake, especially among high-risk populations?
The main one is awareness. I think we struggle to make people aware. I'm part of a group that's looking at that right now. And oftentimes the mechanisms for making people aware are poor. And I think we need to improve those mechanisms. And to your point, we have access to so much, but I don't think we do a good enough job of utilizing those access points to make people aware. I think another one is fear and stigma. I talk to a lot of patients who, you know, after the fact of getting a lung cancer screening and asking them what took so long. And part of it was, I didn't really want to know what the test might result in. And I think as clinicians, we have to do a better job of that patient-provider communication around reducing that stigma, reducing that fear. Those would be the top two that I think. But just to add again, that patient-provider communication. I do a lot of work also at the clinician level to understand what that conversation looks like. And a lot of clinicians, just in terms of tobacco cessation, will tell me, if they told me they didn't want to quit, then I don't know what you want me to do about it. And it's our job to go beyond that answer, because it's our job to provide care. And we have to be vigilant. But it's tough. And so skills training in that regard is paramount to me, to make sure that more people are aware and we can get beyond those types of barriers, even perceived barriers, not necessarily specific barriers, but perceived barriers to accessing that treatment.
Thank you. And I'll ask this follow-up to you, Dr. Celestine. So how can precision prevention better incorporate behavioral and social data along with clinical risk?
Yeah, I think again, it goes back to putting all that information together, but there's the pragmatic side versus the research side, right? On the research side, we're trying to find the, information.
Hello? Yeah, they're all out.
Maybe I can speak loud enough?
I'll tell you what, do that while I find out what's going on my phone.
I don't know problem. I mean, you have clinical data, right? You have behavioral data that's being collected. We don't do a good job of incorporating genetic data at the point of care or after that. So there are genes, nicotinic, related to metabolism, related to dopamine, related to the nerve that we aren't seeing right now, but that potentially can be collected and used to help shape the type of treatment. Because smoking is very difficult. It's considered a chronic disease. It will take more than one attempt. So we have to be able to understand where a person is, both behaviorally as well as genetically, and socially and economically to paint the right profile to drive the right treatments to someone.
That's where motivational interviewing is very important. Absolutely.
See, one of the things I do when I want a patient to quit smoking, the next follow-up I always request, can you bring your spouse with you? And when they bring the spouse, I even make the follow-up time earlier. And then when they come, I take the permission and then say that the importance of quitting smoking not only for the person particularly, but also for the family, the secondhand smoking. Once you give the full picture, the spouses start pushing them for tobacco use, quitting. And so we involve the family. And I would go even one step further to start involving the community. I mean, most churches have health clubs. We should take advantage of those health clubs to get push pressure. And one of the things we often miss is the use of community healthcare workers. Because those community healthcare workers come from that area. We call it whatever, a small village, small town, county, whatever. They speak the language. They know who the leaders are, social leaders. And they know what the resources that community has. Who are the primary care doctors who will help do MSET test, for example, when it becomes free. So there are 7 deep south states. They all have the same issues. And once we start using these community healthcare workers, help, we can make a big one.
Could you tell us a little bit more about what motivational interviewing is?
Just getting to the patient's why. Understanding, what's important to them in their life and their health. I usually ask my patients if you could share with me 3 health goals that you would want to accomplish, say, in a 12-month period of time. I'm Dr. Karen Pendleton, and I'm trained traditionally ophthalmology with fellowship training in cornea and refractive surgery, but my partner, Dr. Jack Ward, and I have been very involved in the last 27 years as it relates to longevity medicine. Helping our patients match their lifespan, which is your years of life, with your health span, which is your years of life, but having that lifespan full of joy, love, blessings, and vitality. And what we know currently is that there's about a 13-year discrepancy between lifespan and health span. And some of these behavioral issues that we're faced every day for our patients are either accelerating, that disparity or narrowing that. So thank you for letting me speak.
So, when y'all interview a patient, or even on the form, how the other thing with motivation, you have people who have, they're not gonna change, and then all the way through the spectrum of, they don't know how to change, and so sometimes you have to like, if you have somebody that's never thought about changing, it's really a challenge to get them to even think about changing. And we have people that we see on a daily basis, and, you know, we talk to them about not smoking, and they say, I'm not gonna ever quit smoking. so, and then you can talk, do a conversation about, okay, this is what we found, and these are the options that we have, as opposed to getting somebody with, you know, right off the bat, you have cancer or you have a bad diagnosis. And really, in my experience, you know, cancers, I never told anybody that they had, that there was a bad cancer. And I would tell them, this is what I found, this is the approach that we're gonna take. And then I would explain to them what we were gonna do, and I'd find out, the key question, I think, for your philosophical is, we have a lot of different therapies we can use. And for me, it was like, which one of these therapies fits into your lifestyle? Because I think understanding what a person's lifestyle is makes a difference in their care.
Thank you for that addition. And Dr. Fong, so we're not replacing existing systems, we're potentially layering and refining them. I think that's important to note. Dr. Vijay Kumar, imaging has long been a cornerstone of early detection.
Thank you.
Imaging has long been a cornerstone of early detection, and it's evolving rapidly in this precision space. How is imaging evolving to support more precise, risk-based screening, particularly for lung cancer?
Very important. Hear me? Probably I don't even need it. There are so many ways imaging can be improved in terms of implementation science, because it's not how many nodules you detect. See, AI can detect more nodules, but how important are those individual nodules that are being detected? So there are things that the AI can help, for examples, something called radiomics, where you can look at, see, with the EHR, you can go back to 10 years of imaging. And the radiomics can look at how the image, texture, volume, things have changed, so that it can predict the risks much better than just measuring the nodule, 3 millimeter or 2 millimeter, and also volumetrically. The other aspect we should focus in the future are radiogenomics, just like pharmacogenomics, where we should be able to combine holistically a patient's family history, his or her smoking history, alcoholic history, rural versus urban living, how far that person lives from access to something that is important. And then, in addition, look at the radiomics, radiogenomics, so that it's extremely holistic. That's where AI can help. So the American College of Radiology 2 years ago came up with a modified definition where some of the nodules, they are very benign and small. We focus on them. Instead, we should focus on what is important. And the new recommendations in 2022 are being implemented. So those are the ways, especially in lung. I mean, we really have a very low dose CT scans, and they do pick up. And then the implementation becomes, say, when the new recommendations say they take into consideration the risk projection for that particular patient, so that that particular patient may have to be seen again in 3 months instead of 6 months. Those all are important aspects, and it's going to even get better every day.
what is, there's a lot of young people smoking marijuana and vaping, and they feel like these are safer alternatives to tobacco. What do you think about this? And secondly, for those patients who are worried about radiation exposure with low-dose CT on a yearly basis, is there any coverage for liquid testing?
To your first question, I'm concerned what the field is debating right now. There's a sense of, I think you have to look at it from youth versus adult with e-cigarettes at the moment. From an adult perspective, studies have shown that it can help you quit, but we don't want that started at a youth age, especially even not just adolescents, but young adult age, 18 to 24, because nicotine can still affect the brain development up until 25. And so another aspect of this is combustible cigarette use has gone down dramatically. We're at 15% right now in the state. E-cigarette use has gone up dramatically. We're at 10% right now, and it's gone up at least 4 percentage points in the past 4 years. So what we have to remember is we're not collecting, as much data as we're collecting, we're not collecting enough data sometimes, because what we can't tell is whether or not this population is quitting with e-cigarettes or is trying to substitute and can't get off of both and are less likely to report that they're using a vaping product. And the EHR has to put that in the right place for clinicians to document it when they're asking about all the other things that they need to be asking about. And to your second point, I'll let others talk, what we usually tell the patient is it's called low for a reason, and try and reassure them that the studies and the practical application of LDCT screening has been shown effective. But we have to do a better job in health around health communication as well, as we talked about earlier. And I think that takes more conversation around personability and, as you said, shared decision-making to make sure that the messages that we're trying to convey are taken in the best way. That's just my thoughts on those two.
Yeah, just on the topic of complementarity between low-dose CT and MCED tests in individuals who smoke. While we're all familiar, of course, with lung cancer as being a byproduct and higher risk for that cancer in smokers, smoking, as we all know, is a risk factor for multiple types of cancers, bladder cancer, pancreas cancer, and so forth. And that's really where there's a huge benefit in complementarity and looking at how MCED tests can be beneficial for smokers because of that complementarity with the ability to screen for cancers that we don't typically screen for today.
The only other thing I would add, there is a concept called ALARA in the use of X-rays in radiology and related sciences. ALARA means as low as reasonably achievable. So this concept kind of balances between risk versus benefit. If the risk of LDCT doses are much better than in terms of overall outcomes and survival and picking up real bad lung cancer, until the MCEDs become more easily available and detect lung cancer, we can use it. And then when the time comes, the ALARA may tell that LDCT is not the right thing to do at that time, then we can shift. In other words, these are not constant, these are dynamically changing things. Every year, it's going to, we have to reevaluate, and right now LDCT is good, but it may not be once there are better, MCED tests. But right now, the usefulness of MCED test is upon the cancers that are very difficult to detect, pancreatic cancer, esophageal cancer, ovarian cancer. Whereas for cervix cancer, breast cancer, and colorectal cancer, we already have very good screening methods right now. Sometimes it is, we should be futuristic, but we also should implement what we have already to take advantage of what we have. Sorry if I took too little time. I sometimes get passionate.
That's okay. Do we have any other questions or comments from the audience? Absolutely.
You know, like Dr. Karen said, like, we've been doing longevity medicine for a while, and so I've studied the blue zone. So if you look at the people who live to be over 100, they eventually pass away from the same things that we're treating today. They get cancer, they get heart disease, but they get it at a later point in their lives. And if you look at the three things that make a difference are, one is socialization and one is decreased stress. And sometimes I wonder if what we're looking at mortality, which, you know, Dr. Fung talked about, but maybe what we really need to look at is how do we accomplish treatment with decreasing the morbidity. But the other thing that I've watched over the years that, you know, the medical profession, where we fall short is in that socialization. We don't take care of the families. So, you know, getting to the behavioral stuff, so how do y'all see us using all this data, using all these new technologies to really push that longevity so where the health span does match the lifespan?
You hit it on the target. I mean, cancer is not an individual disease. It affects the family. It does. And so that's one important thing. And the last question he asked, I'm sorry.
How do we use the science that we're now talking about to help people's health span match their life?
Yeah, exactly. I mean, the point is implementation science. And also what we have right now, sometimes is just for right now it's just good. And we don't need MCED. I mean, we should do clinical trials and all that. MCED will help. But we do, I will give a good example of colorectal cancer. So we all think colonoscopy is the thing to do. But sometimes somebody living 100 miles from colonoscopy facility, and you have to take a day of preparation, a day to come, somebody has to bring anesthesia, and then may lose another day. 3 days of working days is too much. For them, there are other screening methods that are available, that are closer and possible. So it's not, we should be so rigid. We have to structure each one to the circumstances of that person. The best screening test to me is the right screening test for the right person at the right time.
So in terms of health span and lifespan, you know, that can often be framed as quality of life. And what I think we want to do, and you know, MCED's entire thesis is if we can detect cancer earlier, the treatments are less invasive, less toxic, and hopefully you get both. You get a better quality of life in your post-cancer journey, and of course you can extend life. And last night at a dinner program, Dr. Myers talked about an anal cancer that was detected by Gallery, that because it was detected at an earlier stage, the patient did not need a colostomy, and that has a huge impact on quality of life. So as I think about how we integrate these different approaches to screening, surveillance, and other approaches It's really about how can we think of this as a journey and how can we help each phase of that journey.
I'm going to go innovation-wise. I'm going to say virtual reality. I think one of the challenges that people have in changing behavior is that they don't see the change occurring right then and there because it takes time. I think if we provide opportunities for people to see what that change might look like, whether or not it's a change in the family's dynamic, if cancer is developed, or if it's a change in, expected outcomes, if that cancer is developed or it's mitigated. I think we tend to see what's right in front of us, to your points about the data that we have. We tend to see what's right in front of us as opposed to understanding what it would look like if we did get screened and that test came back wherever it came, or if we did get cancer, what treatment might look like, or if we did mitigate that cancer, what life will be like in celebratory fashion. We don't perceive things far out. It's tough for us. I think we need to see that virtually sometimes, in my mind, this is innovation-wise, so that we can look forward to something. That's my thought.
Thank you. I think we're out of time. We've heard today that precision in cancer prevention and early detection isn't just about technology, right? It's about alignment, aligning risk, behavior, access, and systems. As detection technologies and prevention strategies continue to evolve, the real challenge and opportunity is translating these advances into approaches that are scalable, equitable, and capable of improving population health. Thank you to our panelists, and thank you all for being part of the conversation.
It's lunchtime, so grab some food and head on over to our keynote talk.
so when we scan clinic records, find people who are due, and then push this out to them directly, and they click on it, and it's their local Costco, or it's their local high school football coach or something saying, you're due for your, I mean, I'll make it nicer, I'll make it more professional, but what are you doing? Go get your screening, you know, that type of thing. So that's, yeah, yeah, so that's what that project is. We're going to get that started. Hopefully in the fall, we'll see when I get back.
Yeah.
But yeah.
So, that population is located in kind of southern, is it, or is it?
So it's west of here, so I would say south, probably central, south central.
How's Baton Rouge or?
Past Baton Rouge, yeah, west of Baton Rouge, so it's between Baton Rouge and Lake Charles. Yeah,
Okay.
yeah. And there's a whole, you know, when you hear the kind of like stereotypical Louisiana, New Orleans accent everywhere else, that's the accent they're on. Yeah, that's the accent, that's the Jason accent, they're all kind of copied.
Yeah, it's interesting. So we have a colorectal trial that's getting ready to get started. It's in a very specific patient population. KRAS is like the big mutation, so there's a lot of KRAS inhibitors in there, but that mutation rate is like 5%, right? It's a very small amount of the patient population, but yeah, so it'd be interesting to know. I know there's colorectal prevalence is kind of high in southern Louisiana, so trying to help find some sites that would be good to use that.
Yeah.
Try to find.
We need connections to the tumor industry, they would be able to, they have data, for basically anyone who is diagnosed with any cancer has to report it too. So they would essentially be able to, should be able to, request data and look, and it should also have location, like where they were,
Yeah.
like which hospital, or at least give you some kind of, so if you can, map that out
Yeah,
and
zero
you can
time.
see,
Yeah.
yeah, so that would be, that would be my suggestions, that Louisiana Tumors, they're also out of LSU, which is why I know, I'm on the third floor, I'm the
Yes.
second floor.
That's cool. I'm just wondering, like, Braille has that new health test, right? So that scans the picture. I wonder if that's, you think it becomes more accessible. I mean, obviously the outside is cost, but are patients more willing to give blood as opposed to for a scan, or is it just,
I think it's
how do you get
easier
over
to
the?
sell.
Yeah.
I think it's easier to sell, and it's also, you're already giving blood for cholesterol, all these, now you will still hit the skepticism.
Yeah.
Why are you taking more blood, or what are you gonna, you still hit that, and I think it's definitely more acceptable. And it's, it's fairly straightforward, unless someone has some, innate fear of needles, they're probably gonna, versus a scan that, is this radiation, or they might have to go to an imaging center, they might have to go somewhere else with a blood test that they just get at the doctor's office.
Right.
Yeah, yeah.
Dr. Celestine brought the point cycle, but do you kind of want that, like, you go in expecting just, okay, your cholesterol's high, but do you expect to walk out, well, we detected cancer?
Yeah, yeah.
It's like, would you rather know or not know?
Right,
It's like,
yeah.
it's tough.
Yeah, no, it's tough, and I get that all the time from people who just, they just not know things. For someone who doesn't think like that, it's hard to understand, like, you can believe it, it's that deniability of, okay, I don't think about it, or, okay, now you've told me, I don't know how to do treatment, I don't have, I'd rather not know, and, I just die away from my family's fine, it's just me and my family, so, yeah, it's tough, yeah.
spend enough. Okay. So let me get rid of everything from the last crew. 9:30 is, so I have you here for 2:30. I'm just gonna
Correct.
cancel that,
Mhm.
so it's not even up. Bratton. Bratton. Okay. Okay. So if you'd like, is there a thing on this?
We should probably do this one here.
Is this your first time here?
It is.
Okay, okay. Couldn't remember if I recognized it.
Mm-hmm.
You driving from out of town?
Yes, it's, East Bay, San Francisco area.
Oh, that's a far ways away.
Yeah, it was a while.
Man, I bet that TSA.
You know, it wasn't too bad.
Really?
Believe it or not, it wasn't that bad. You know, I walked straight through and didn't have a problem with the lines at all. Yeah.
I'm surprised, actually. I
Me
mean,
too.
given.
Me too.
Okay. I know a bunch of folks are worried too because they're coming here and they're flying out as well and they're trying to.
I wonder how bad it is over at Louisiana. Do people say it was bad also, or?
I've heard mixed things. I guess it depends on when your flight is, what time it is. Yeah.
So it's, mine's later today, so hopefully there's no issues, but
Yeah.
we'll see.
It's looking good. Everything's fine.
It's kind of weird. I had saved it in a different format, and all of a sudden all of my changes I see are perfect, but it's fine.
Sometimes that happens when I do it with Google Drive because I'll receive it in PowerPoint and I upload it to Google Drive and sometimes it's formatting. But this was not uploaded to Google Drive, so I'm surprised.
This is,
Well, you got it, huh? You're just gonna skip. Yeah, you got plenty of time.
Perfect.
And all the other presentations are open for the block. So just leave yours open and then it'll be ready to go when you're
do
ready.
you want me to save it onto your computer or not? Save it?
I would download it on the computer
Okay.
just in case, so it's there for whatever reason.
No problem. Thank you. I'll take care of all
Yeah.
this.
And do me a solid, just plug this guy. Actually, there's two here. This is for
okay. Thank you.
if it's during the daytime, because one time your husband and I were, me and husband, they make up one more person in the plane, maybe a little bit here, and they called him out, and so, they chased elevator up, and so it ended up being his patient, but it was 5:45. And so, they were down two nurses, and said, and it was a seizure. And so, I looked, I had pushed the medicine in like 9 years. And so, look,
I want to add my presentation
For
for right now for 2 o'clock.
okay. And this is your name?
Ramsey Abdelghani.
Oh,
So,
gotcha. Okay, you have an update. So I remember we discussed this. So this was your PDF. You have an updated version?
yeah, I have it right here.
Okay, that's perfect.
Yeah, it's got a good video and all that kind of
Yeah,
stuff.
just go ahead and plug it in.
Can we close this?
Yeah, because that's your previous. I had it as a placeholder, so go ahead and use that. I open it and save as if you can. But honestly, whatever, so long as it's on the computer.
Okay, let's put it here. It's kind of big, so I couldn't email it to you.
Yeah, okay. Really, the like preparation, which you need to review for CME.
For sure.
Beyond
for sure.
that, we could just do this like we're doing, and you're good to go.
All right,
So
cool. Thank you.
whatever.
I appreciate it.
All right. And that's it. No changes. You're good to go. For you?
Yeah, yeah.
Okay. Cool.
Yep, thank you.
Yeah. Well, she came here with the picture. I took it. Well, yes, it is, right? I'm gonna come back. Maybe I'll go. I don't. The printer's out of my house. So much. I'm well. How are you? Yeah, yeah.
Mic test 1, 2.
Mic test 1, 2, test 1, 2, check, check. Mic test 1, 2.
Check, check. Check, check. Down the street, it's like, you know, I don't need hotels here right now. Exactly. No, I've been here several times.
It's hard to keep dying.
Yeah, that's, oh, that's so good. It just goes down so easy. Go back to that restaurant, that Brazil.
Yeah, I told my wife about it. She's a big
There's times when I was getting I don't know these guys, but you know, I gotta spit this out. These guys are gonna be fishing out, phones out my esophagus. Like how great this guy is. Never invite him anymore.
Yeah, I met this guy. Perfect. More than we bargained for, that's for sure. Good, good. Let's check here. We're good there. I'm not, yeah, we're just gonna be introducing. Probably this. We're about to get started now. So. Speaking. There'll be 4 speakers. Okay, yeah, there won't be a, like a panel discussion, so it'll just be, you know, presentation and then question. Oh, I see, yeah, we should do that. All right, we're gonna go ahead and get started. Good afternoon, everybody. My name is Jordan Dozier. I'm a thoracic surgeon here in the city at Ochsner. And thank you, everybody, for being here. It's been a real privilege to serve as the lung block chair here for CAGLA. I've been involved since 2021, and it's been really incredible to watch the organization grow and watch the meeting grow, not just in size, but in depth, discussion, and collaboration. And one of the things that I've really enjoyed about being a part of this organization is strengthening the relationships with new physicians as well as old physicians that I've known in this cancer space. And so today, what we're going to do is try to bring you inside a true multidisciplinary conference. You're going to hear multiple perspectives from not just thoracic surgeons, but interventional pulmonologists and medical oncologists. And we're going to be highlighting the teamwork it takes to take care of these cancer patients. It's these
different lenses that make the discussion richer and really help us to learn and grow in our individual practices. So we're going to hear from some of the best, not just regionally, but from across the country that they've come in to talk to us. So I'm really excited to hear what everybody has to say. So first up is Dr. Abdelghany. He earned his medical degree from Jordan University of Science and Technology, completed his residency here in Louisiana at Baton Rouge General, and his pulmonary and critical care fellowship at Tulane. He then went on to do his interventional pulmonology fellowship at Harvard and trained at Beth Israel Deaconess and Mass General. He's now assistant professor and director of interventional pulmonology at Tulane, and he has clinical and research interests in peripheral lung nodules, malignant airway obstruction, as well as cryobiopsies. And today he's going to be talking to us about the diagnostic and therapeutic modalities in interventional pulmonology. Thank you.
Hey, good afternoon. Like I said, I'm Ramsey Abdelghany. Thank you all for making the time and coming out here. So I kind of want to give a little perspective on interventional pulmonology, how we help the thoracic surgeons and medical oncologists, and how we play a role in the treatment landscape in taking care of cancer, helping diagnose and palliate lung cancer. So points of discussion, I want to talk about what interventional pulmonology is, some of the diagnostic tools that I found very valuable in our field and to help minimally invasively diagnose and treat and help palliate lung cancer, and some therapeutic tools as well. That way these patients, when they come in more short of breath, we can help relieve that difficulty breathing and have them more robust and be able to get treatment under y'all's care, and future directions, of course. So interventional pulmonology is a procedural subspecialty. It's minimally invasive and aimed at diagnosing and treating various pulmonary and pleural diseases. It takes a page from uses advanced diagnostic and therapeutic interventions with bronchoscopic and pleural techniques. How you get there, I'm a medicine doc, so I'm a little different than our surgery colleagues. I did 3 years of internal medicine, followed by another 3 years of pulmonary and critical care, and finally a 7th year of interventional pulmonology. So a longer road than it probably should take, but this is kind of the current way we do things here. So the kind of the landscape of what we treat, it's a wide array of things. Mainly, my passion, my focus is helping diagnose lung cancer. We can also help with people who have difficulty breathing in COPD and bullous emphysema. If you have tracheobronchomalacia or excessive airway collapse, we can aid in that as well. Any kind of fistula, typically we're part of the treatment team as well, whether it be tracheoesophageal, bronchopleural, or alveolar pleural. In hemoptysis, again, typically we're part of the team as well, helping get culled and helping localize and stop the bleeding and queuing it up for interventional radiology or thoracic surgery to get the final treatment. ILD, chronic bronchitis, again, we won't mention in this talk, but again, we can kind of help encompass most of the respiratory diseases. So some of the advantages of bronchoscopic biopsy, of course, I'm biased because it's what I do for a living. I don't do CT-guided biopsy. So it's a minimally invasive procedure, much like CT-guided biopsy. It's typically an outpatient procedure. There is minimal risk of complications when compared to CT-guided biopsy. Typically, traditionally, the data shows around 20% pneumothorax rate for CT-guided biopsy because you're puncturing the lung every single time. We're going inside the lung or inside the balloon, so our risk of pneumothorax is significantly less. It also can help our surgery colleagues if there's a small nodule they may not be able to feel with their hands or with the robotic surgical tool like the Da Vinci. We're able to mark these areas with some dye or a fiducial, depending on the surgeon's preference, to help localize these lesions so they can minimally invasively take these out and can preserve lung tissue. At the same time, we're able to basically, after we biopsy the nodule, we're able to also stage the mediastinum, providing a one-stop shop where we can diagnose and stage the lung disease or lung cancer, and that can help expedite the patient's care, decrease time from diagnosis to treatment, and give a better picture for our radiation oncology, medical oncology, and thoracic surgery colleagues. So navigational bronchoscopy has been around for many years. It came out as electromagnetic navigational bronchoscopy, and now with the advent of the robot has become more accurate and safe to do. Essentially, I think of it like a lung GPS, right? I think of it like a big old oak tree. I always tell my patients to go down the trunk, down the branches, and I'm going to one specific leaf on that tree. You can see there's hundreds of branches, many bifurcations, can be very challenging to get to. So having a device or platform to help us get there is very helpful. And came the robotic bronchoscopy. Data shows the average diagnostic yield is about 84% compared to CT-guided biopsy between 80 and 90%. If you add advanced imaging, basically you have CT-guided biopsy by an interventional radiologist, and now we offer CT-guided bronchoscopy by an interventional pulmonologist. And that increases your diagnostic yield to around 95%. This is kind of the console we use that we can control, and it can be done. It's kind of the little brother of the Da Vinci. We kind of are able to do this in an outpatient setting. This is a screen of how it looks like when we plan our cases based on the device that we use. The robot will segment the airways for you, but you have to make the plan itself. You take that plan, put it on a USB, plug it into the device, and the day of the procedure, it'll help guide you to that location. So we've come a long way. Back in the day, it was, CT-guided biopsy was king, right? Had the highest diagnostic yield, and it was the one that everyone kind of referred to as the culture that was provided back then. We got our diagnostic yield from conventional bronchoscopy was quite low, thus most bronchoscopists would send to IR for biopsy. Once we got electromagnetic navigation, we got a little better, but still, a lot of times I would find myself sending to interventional radiology, and I'd find myself asking the question, could I even get to this? It looks really challenging. Let me do the best for the patient, send it away. Now with robotic bronchoscopy and advanced imaging, I'm able to get a higher diagnostic yield for bronchoscopic biopsy, a lower complication rate, and really the culture has changed from can we do this to should we do this? We can get to anything now, but should we be biopsying a 4-millimeter nodule? Should we be biopsying certain areas that may not be as concerning, which is very exciting now to have that change in landscape. This is a quick little 1-minute video of us doing the procedure so you can see what it looks like. You can see on the left of the screen, or the screen I'm looking at, is the virtual airway that the robot gives you. That's what it kind of digests and gets from the CAT scan. On the right of the screen is the real airway. What you have to do is tell the robot where the airway is. You'll do something called registration, going into the left main stem bronchi, go to the right main stem, upper lobe, lower lobe, etc. And then the robot will kind of understand what's going on, think for a second, and give you a treatment plan or a path. Here you can see I'm just going to follow the blue line. It is pretty accurate, what helps us go, and you'll see all these bifurcations that traditionally can be very challenging to get to. A lot of people around the country don't have access to the robotic bronchoscopy, and they do things with just a bronchoscope and a dream. And they're very good at it, but they don't get the diagnostic yield we get here, which is, again, a testament to the advanced technology we have. After localizing the area and following the virtual target, we get an intraoperative cone beam CT image that'll help show our accuracy, and we're aiming something called tool-in lesion confirmation, much like CT-guided biopsy does. Once we get that, we'll use the robot under fluoroscopic guidance to biopsy the nodule. This is a nodule right on the diaphragm, so a very precarious location. We can do this safely and accurately with a high diagnostic yield and a low complication rate. So a couple of cases very quickly. This is a case, one of my first 10 or 20 robots. I was still in the mindset of, can I get to this? It was a 3-millimeter nodule, grew to about 7 millimeters right on the fissure. I sent this to interventional radiology. They said, I don't want to go through 2 fissures. Our risk of complication is a little bit higher, so I think right now it's something we'd wait for it to enlarge and get bigger. So we went after it with robotic bronchoscopy. We went in with intraoperative cone beam CT imaging. This is a sagittal view of the CAT scan. You can see my robotic arm, if you can see my pointer. Is that working? No, you can't. What about here? No. So up above that nodule, that blue circle, is my needle, and to the left of the needle is my bronchoscopic channel, is the robot. You can see here I'm a little superior over the 7-millimeter nodule, so I knew that I was going to get a non-diagnostic biopsy had I biopsied there. With the advent of advanced imaging, I was able to move inferiorly because the robotic catheter fully articulates, and that allowed me to get a center strike. Because you can see here the needle's inside the lesion, right in the middle of the target. It is not touching the pleura, not touching the fissure. We're able to get a diagnosis of adenocarcinoma here. The patient did not have a pneumothorax. She went on to get a wedge resection and was cured of cancer. Traditionally, we'd have to wait for this nodule to increase for another modality to be able to go after it, but now we're kind of hopefully stage shifting, going after smaller and smaller nodules and being able to get as early of a diagnosis as possible. Another one, this is a, which I think is very important. It is a 3 by 5 millimeter nodule that came from an outside hospital. The patient had a history of adenocarcinoma. This was worrisome to be recurrence of disease. So getting a timely diagnosis is extremely important because you're not able to restart therapy without getting a diagnosis. Now, traditionally, you would wait for this size to double to go after it, but with our new technology, we're able to do it. Here is the intraoperative images. This is, on the bottom left of the screen, is a 360-degree ultrasound. It shows that I'm close to the lesion. And under fluoroscopy, you can see it there. Intraoperative cone beam CT. The right of your screen is my bronchoscopic arm and a cryoprobe catheter touching the lesion. That made me feel more confident that I was going to get a good answer. I do have pathology at bedside who can tell me, I think you're in something, I think you're not in something. This came back as metastatic adenocarcinoma, and the medical oncologist could start treatment then and not have to wait 3 or 4 months for this lesion to double. So she was able to act on the patient's behalf much faster because we're able to get the diagnosis so much sooner. And an interesting case, this gentleman came in. He came after a dental visit. He had a chronic cough. The dentist said, it's probably nothing, don't worry about it. They ended up referring to a ER in Mississippi. They got a chest x-ray. You can see a metallic object here in the posterior basal area of his lung. There, at that hospital, it was a surgeon who was willing to do a wedge resection. The patient initially did not want a wedge resection, so the pulmonologist referred him over to us and transferred him over from hospital to hospital. We went in, again, nothing I could do that a surgeon can't do with surgery-wise. I can't take that out. So I tried at least. What we ended up doing was, here's a CAT scan of the same thing. Again, very, very far away, very distal. So traditional modalities could not retrieve it. Let me play this real quick. So we ended up planing the case with robotic bronchoscopy, and were able to grab the metallic object and actually drag it through the working channel of the robotic bronchoscope. It took a little bit of time to kind of finagle because I was worried that if I dropped it, it would kind of, like a game of Plinko, it would just get back somewhere else in the airways and I'd never find it again. We were able to kind of successfully remove it. And any guesses what this was? Anybody know? Yeah, so dental drill bit, yeah, that's right. So this is one of the tools the dentists use. Typically, when I talk to one of the dentists, typically patients swallow it. They don't lose them very often. Typically, they swallow it, they tell them nothing to do, it comes out, and you're fine. Unfortunately for him, he was a little sleepy and inhaled it. So this kind of saved him a surgery, which was great for the patient, and it was a cool case that got us on the news. So very exciting. It was actually kind of funny because my mom got a dental procedure maybe like 2 or 3 weeks after that news story came out. And the dentist was like, yeah, some jerk is talking about how bad dentists are. And she's like, I don't know who that is. I'm not going to comment while you're inside my mouth. I'm going to stay quiet. But he was complaining about that to her, so that was kind of funny. I want to transition from more diagnostic to more therapeutics and how we can help the treatment team. Central area obstruction is a very dangerous disease that can happen to patients with lung cancer or metastatic other types of cancer. It can happen up to upwards of 50% of patients who have lung cancer can get some sort of airway obstruction. This can significantly, decrease their quality of life, of course, and it can worsen their ECOG, so y'all aren't able to treat them or do things for them. We can go in and, a third of these will actually die from these complications. And bronchoscopic minimally invasive procedures are a mainstay of treatment. Typically, these are not surgical candidates. If they are, surgery is the mainstay, but if they're not, kind of typically they come to us. There are 3 types of obstruction. I'll very briefly go through them. One is intrinsic obstruction, where the tumor is confined inside of the airway. I go in, kind of like a plumber. I go in, core that area out with whatever tool I use. Don't have to do anything else, and the patient goes home that same day feeling better. There is extrinsic compression, as a large lymph node or large mass can squish or compress the airway. Typically, I'll go in, throw a stent in there, the patient will get better, and continue getting treatment. After treatment's done, I can hopefully take the stent out, and the patient can go on their way. The most complicated form of obstruction is the mixed, and that means there's an extrinsic compression that has eaten through the airway wall and now has become intrinsic. Those are a little more challenging to do, but again, we go in, remove the tumor as best we can, place a stent, and hopefully improve their quality of life so they can get treatment. This is just a quick array of some of the stents we can place. Nothing for y'all to really focus on, but they're silicone, metallic, covered silicone, uncovered metallic, a bunch of different kinds. And there's a Y stent in the bottom right corner if they have significant tracheobronchial disease. We can place those as well. There is some data of this. So they did a study where they found patients who came in intubated and on mechanical ventilation because of their central airway obstruction. After they all went to rigid bronchoscopy and got that tumor intervened upon, about 2/3 of them had immediate discontinuation of mechanical ventilation, meaning they were extubated from the procedure suite and went back, and half of those patients actually stepped out of the ICU down to the medicine floor. So I'm usually caution our patients, you're likely, if I can do a good job, you're likely going to feel better after the procedure. And these are patients who I'll get from around the state where I'll do this as an outpatient procedure. They'll drive in 1 or 2 hours from wherever they're coming from. I'll do the procedure, put a stent in, and they go home that same day feeling much better, typically. They also did another study where they had patients with non-small cell lung cancer. They followed them. They had patients who had central airway obstruction and patients who didn't. And the ones who had central airway obstruction obviously passed away much sooner, but had they gotten intervention, they live as long as someone who never had any central airway obstruction, which doesn't sound that great to begin with when you think about it, but they're living as long as somebody else that has clear lungs, if that makes sense. And again, we can help make patients feel better, and also we can increase the ECOG by 1 or 2 points, making them eligible to get treatment or radiation or chemo when before they could not because they could not walk, and they spent most of the time in bed from their respiratory disease. A couple of quick examples. This guy was from back in IP fellowship. He came in from an outside hospital, never been diagnosed, kind of, chronic smoker, just felt more and more short of breath. You can see the right side is completely occluded. The mediastinum is going towards the right side. So if you remember, put on your old internal medicine pulmonary hat. It means likely a loss of volume, unlikely a pleural effusion. We got a CAT scan, something called the cutoff sign. You can see the right main stem completely cut off, indicating some sort of blockage, blood, mucus, or some sort of tumor. This didn't come as good as I thought it would come up with it. There's a large tumor right there, occluding the right main stem, and that's why his right lung was completely occluded. After tumor debulking, we placed a stent. You can see now that the healthy airway is visible. The stent is opening things up. He was able to go and get treatment afterwards. This is a chest x-ray after the procedure. You can see the right lung was more open. He still had some volume loss from where the tumor was originating, but we're able to open up 2 out of the 3 lobes. This is a crazy case that I found when I was, I think, my second year being attending here. This is a gentleman who had squamous cell carcinoma. I think he came from Lafayette, if I'm not mistaken. He had a left pneumonectomy for his squamous cell carcinoma, came back maybe 2 or 3 years later with worsening shortness of breath. The pulmonologist over there sent him over to me. Very salt-of-the-earth guy. I kind of asked him, are you short of breath? He's like, no, I feel okay. And I'm having trouble believing that. And the more I talked to him, like, can you lay down? He's like, no, I can't lay down. No way. I couldn't lay down for a year. All right, can you walk? He's like, no, I can't really walk very much either. So I'm like, okay, I think you are probably short of breath. So we convinced him and took him to bronchoscopy. This is what we saw inside this is his trachea, right, the main airway. On the left is that sliver of black. That's where he's breathing from, which is absolutely insane, that he has 1 lung and 5% airway, essentially. We're able to get around that. We removed it in a very tenuous procedure, as you can imagine. This is it after the procedure. We removed the whole thing. You can see he's going to feel much better. We burned off the stalk from where it was growing from, and then 6 weeks later, we brought him back. It looks like nothing even happened. In post-op, he woke up and he goes, oh, you're right. I do feel better. No, I was short of breath. Forget everything I said. This is way better. Never mind. I'm sorry. Here's another patient who came from an outside hospital, came in. She was a DNR, but had history of small cell cancer that had progressed, and she came in on BiPAP and high flow nasal cannula, et cetera. We accepted her, took her for bronchoscopy. This is, again, for the main trachea, the trachea. You can see all that lumpy bumpiness around that trachea, very sliver-looking, very challenging. It's about 5 minutes in diameter, just kind of like an IP emergency. We went in, burned some areas that were bleeding, and used a balloon to open things up and placed a stent. This is it after the procedure. Again, patient was discontinued from BiPAP, discontinued from a high flow nasal cannula, went home off of oxygen. Again, she still has metastatic small cell lung cancer. I'm not saying she doesn't, but she was able to live another 3 or 4 months. She was able to cook dinner for her family and Thanksgiving and saw Christmas and then passed away. Last but not least is the future directions that we're trying to go with. Again, this would be huge for my personal practice, just because I'm good at diagnosing, I'm good at palliating. I don't have a lot of options to treat. That's more for the surgeons and medical oncologists and radiation oncology colleagues. But bronchoscopic ablation is becoming a new avenue for a possible therapeutic option. I'm using a lot of ifs because it's still pretty experimental, but the pleural space is not violated, so you can compare that to interventional radiology, less pneumothoraces and better local control. Ideally, in my dreams, it's a one-stop shop, right? I go in, I diagnose the nodule, I stage the mediastinum. Mediastinum is clear, not a surgical candidate, not a radiation candidate. I'll go in and zap the tumor, and I can have local control. Many modalities are trying to access this space, and it's very challenging to figure out which one's going to be the front runner. We have microwave ablation, many different companies that do that, cryoablation, photodynamic therapy, and pulse electric field ablation. I won't go into too much detail, but each one has pluses and minuses. Not a lot of great data for any one of the modalities from a bronchoscopic standpoint. We're about to start a trial for the next 3 to 6 months for microwave ablation. We're doing some cryoablation stuff, but again, nothing that I could say is really working yet. So overall, that's kind of it. This is our interventional pulmonology team, group of RTs that do this with us 5 days a week. My partner, Dr. Becknell, and our team. And yeah, so if you have any questions, I'm happy to field them now. And thank you all for your time. I appreciate it.
Any questions?
Dr. Abdel Ghani, that was an outstanding talk.
Thank you.
One of the challenges first of all, I'm a major believer in robotic bronchoscopy, and that is now our first choice instead of sending patients to interventional pulmonary medicine, interventional radiology for the reasons that you mentioned. One of the Achilles heels, however, is the amount of tissue that one can obtain via the FNA in robotic bronch versus the core needle. What are your thoughts about cryobiopsy using the robot?
No, absolutely. And I think that is a challenge, right? Initially, you want to be able to get, first of all, the diagnosis, and second of all, the ability to get all the next generation sequencing, moleculars that oncologists will ever need. Cryobiopsy is a great avenue. For what it is, it's a freezing probe, uses the Joule-Thomson effect, rapidly expanding gas, causes a rapid decrease in temperature. Essentially, it obtains a lung popsicle, right? It goes in, freezes tissue, and removes it. It helps retain the architecture, so pathologists can make a better diagnosis. Two, it gives you a much larger amount of tissue. Traditional forceps can give you small amounts, where a cryobiopsy can give you up to 4 to 5 millimeters of tissue in aggregate. So this has been a mainstay of my bronchoscopies. If it's a larger lesion, I may use a forceps, but if it's small, like all these lesions I showed you, I'm definitely using cryobiopsy to get a better amount of tissue. And what I don't want to happen is I do not want to have to do this case again, or this procedure again. So I try my best to make sure I have two lesion confirmation for negative predictive value in case it comes back benign, and to use all the modalities, needle, brush, and cryoprobe to get as much tissue as possible. So far, I would say 95, maybe 98% of the time, there's enough tissue for everything, as far as I can tell, of course. Thank you.
Hi, Dr. Abdelghani.
How are you? Good to see you again.
Great, nice to see you. I was curious about the risk of seeding in the CT-guided biopsies compared to the robotic bronchoscopies.
Yeah, that's a good question. And seeding has been theorized in CT-guided biopsies. There's a study or two that may potentially think this is an actuality. Robotic bronchoscopy, there is no data to support that there is any kind of seeding, as far as I know. But there are certain scenarios where you place chest tubes in melanoma or renal cell carcinoma or mesothelioma. There could be areas of or chances of seeding. We haven't seen much in robotic bronchoscopy, but it's a great question and a great thing to kind of prospectively look at.
I have a question. You clearly showed good data that ION is superior to percutaneous biopsies with respect to complication. What do you think is the reluctance from either primary care doctors or pulmonologists who are following nodules to go towards or refer to ION as opposed to watchful waiting or percutaneous biopsy?
I think it's twofold. One is culture. We've been sending the CT-guided biopsy for 30 or 40 years now, and it has been the gold standard. And in many cases, people think it is the gold standard, right? Second of all, I showed the data of conventional bronchoscopy. There are people like me, past versions of me 10, 20 years ago was like, yeah, of course I can get to everything. And the data showed that that is not the case. When CT guided biopsy remains supreme. Then electromagnetic navigation of bronchoscopy came out, and people said, yes, now I can do everything, send to me. And again, that was not the case. This is the third or fourth time we're telling oncologists and primary care doctors, yes, we can get to everything. This is, now data can actually show us we're actually able to get to everything. So it is a person, it's person by person, I think, and case by case. You have to kind of change that culture. It is challenging, but I think now the data does show I'm comfortable. I've sent to IR maybe once or twice when they can't get general anesthesia. Otherwise, I've done over 1,000 cases and, you know, we're maintained a 90-95% diagnostic yield and low complication rate. Cool, thank you all.
Okay, great talk. So next, we're going to transition from the diagnostic approach to actually a combined approach for both diagnosis and treatment at the same time. This is going to be presented by Dr. Sai. Dr. Sai's journey to thoracic surgery started actually in New Jersey, similar to myself. Trained at Robert Wood Johnson. He did his CT fellowship in Pittsburgh, where he actually met my boss, Dr. Pettiford, and Dr. Pettiford emphasized that Dr. Sai is a leader, not only just a master surgeon, but an innovator and a great entrepreneur. So we're happy to have him here today, and he's going to talk to us about, do we not have his presentation loaded? But it's going to be about SABRE, which is the combination of robotic bronchoscopy combined with robotic resection. So thanks, Dr. Sai, for coming.
Well, thank you for that introduction, Dr. Dozier. And again, I definitely want to extend a heartfelt gratitude and appreciation to my colleague as well for inviting me today. So today, my talk is on this new procedure. It's not new anymore, but when I started evolving it, you know, I wanted to have this fancy, sexy name for it, so I figured I'd call it SABRE. The reason I called it SABRE was because that's the name of my Brazilian Jiu-Jitsu Academy, and I kind of want to, you know, give homage to my my roots there as well. So SABRE stands for Maine Single Anesthetic Bronchoscopic Robotic Event. For me, this is exactly why it's important. And when I found out that today's conference was about patient advocacy in cancer treatment or in cancer diagnosis, you know, I really feel like this was a very important segue to comment on, especially to this very motivated crowd. So this is the problem with lung cancer. We know that lung cancer is the #1 cancer globally, and it kills the most number of people in the entire world. Every 2.5 minutes, someone is going to be diagnosed with lung cancer. And every 3.5 minutes, someone in the United States dies from lung cancer. About 150 to 160,000 new cases of cancer per year. So this is a very, very deadly cancer. And unfortunately, over the past several years and decades, we haven't really been able to move the needle on the survivability of lung cancer. And hopefully, if we pursue avenues as our interventional pulmonologists and our thoracic surgeons have described, I really am hopeful that we can actually make something better, especially for these lung cancer patients. So if you look at this, what happens, of course, no duh, the later we diagnose the lung cancer by stage, the lower their survivability is. And you can see that in most patients in this country, they're diagnosed late stage. Up to 57% of patients are diagnosed when they have metastatic disease. And the real reason why is because the majority of these lung cancer patients, they don't really present with a lot of symptoms. And so over 85% of patients in this country are diagnosed with lung cancer incidentally, meaning they went to the ER, they had gallbladder pain, they get a CT scan, and by the way, besides gallbladder disease, you have a nodule at the bottom right lower nodule, at which time either hopefully they get workup for it, or a lot of times these patients are lost to follow-up, and I think that's the biggest problem here. As alluded to before, there were certain diagnostic options that we had back in the past. Number one was the CT-guided biopsy, that we call transthoracic needle aspiration. As you can see the data there, the diagnostic yield is really high. It's about 90% in many centers that actually have very good interventional radiologists. But the biggest problem with the CT-guided needle or biopsy is the fact that the pneumothorax rate was extremely high. So the pneumothorax rate can be 20 to 30%. And that poses a problem for these patients because now they thought they were going in for a simple biopsy, and all of a sudden they're getting a chest tube in, they're getting admitted, they're staying in the hospital for several days. And not only is that a severe complication for these patients, it becomes a big money loser for those hospitals. So if you look at, our data, we know a CT-guided biopsy in our hospital pays about, $700. But if these patients get admitted to the hospital, then there's a significant loss because that reimbursement is not generated, for those admissions. So the hospitals end up losing a lot of money from it. So then what happened was we started having this new development in electromagnetic bronchoscopies, what we used to know as superdimensional bronchoscopy. And, everyone was touting this as the greatest sort of, thing since sliced bread. But if you actually look at the data and tease out the data, the diagnostic value or diagnostic yield for a superdimensional bronchoscopy, it was still much lower than a CT-guided biopsy. We've all been in that situation before where we're in the OR, you've taken this patient to the operating room, you've administered general anesthesia, and you're sitting there digging away at hours trying to prove that this nodule is a cancer, and all you can do is get the pathologist to say, oh, I still don't see anything that's diagnostic. That's a lot of anxiety provoking sentiment to us because we want to have a responsibility to this patient that when we bring you into the operating room and we give you general anesthesia, I want to come out of this operating room giving you a diagnosis. And nothing is more anxiety provoking than, of course, not being able to do that. So the problem with transthoracic needle biopsies is, it can't go everywhere in the lung. You have problems with the nodule is too centrally located, so the interventional radiologist say, no, the heart's in the way, the subclavian artery's in the way, the diaphragm's in the way. And again, the biggest problem is the fact that it can't also stage the patient at the same time. So when our interventional pulmonologist colleagues go in for these robotic navigation bronchoscopies, they can also do an endobronchial ultrasound at the same time to look at the mediastinal lymph nodes, and now you have diagnosis and staging all in one setting. So this is the reason why the electromagnetic bronchoscopy wasn't a very stable platform and had very low yields. So this is the superdimensional bronchoscopy. As you can see, this is your workforce around this. You have literally 3 or 4 people standing around the patient, and you have the bronchoscopist holding this handheld camera, and you can see any sort of movement changes the position of the tip of the camera. And so in order to really get a good diagnosis, especially the farther and farther these nodules go out, you really need to make sure that that hand is immobile, but unfortunately, because of human factors, that hand will always be moving, at which time the tip of the camera can also change. Even 1 millimeter would change the angulation at which you insert your camera. And that's the reason why these navigation bronchoscopes, handheld navigation bronchoscopes, were so inaccurate, because it relied on human factors and not so much the robotic component. The next slide I'm going to show you, it's a little bit gimmicky, a little bit sort of, commercially, but it does hopefully give the room an idea of why we think, or why I know, and everyone else knows that does this, why the robotic navigation bronchoscopy system is better. So, there we go.
Conventional bronchoscopes are controlled by the human hand. They can lack the stability and maneuverability provided by a robotic system, and they may not provide the precision needed for a lung nodule biopsy. We designed iron to perform precise and accurate biopsies deep in the peripheral lung. Physicians can repeatedly biopsy the same target, while systematically change the sample location in the same area. Robotic distal tip articulation allows physicians to aim the catheter at small targets, even when located outside the airways. Iron's Flexision biopsy needle is flexible and allows it to advance through tight catheter bands and still deploy on a straight path into the target location. Iron's shape sensor provides precise positioning and orientation information. This enables precise control of catheter positioning and interaction between biopsy tool, tissue, and the catheter itself. The user can precisely steer the biopsy needle into different areas of the target. If real-time confirmation of a representative tissue sample is available during the procedure, the user can systematically redirect subsequent biopsy attempts into the confirmed target area. We refer to this approach as cloud biopsy. ION is designed to provide the precision needed for lung nodule biopsies in all areas of the lung. I'm eager to see the system used in a clinical setting and provide physicians with a new biopsy option.
Perfect. So as we, ignore all that, enthralling music and stuff like that, you can truly tell that what this robotic platform does, it gives our proceduralists an ability to maintain stillness and stability, and all the while be able to navigate all the way out to the periphery of the lung, and quite honestly, anywhere else in the lung, as our interventional pulmonologist referred to. So when I started this procedure, I was, one of the first surgeons in the Pacific Northwest to really start robotic navigation bronchoscopies. And, back then, it was very hard for me to get my interventional pulmonologist to jump onto this. And I don't know why, but I do think there's a, significant cultural change now. And so I was kind of stuck here by myself as a thoracic surgeon trying to figure out this robot that this hospital purchased for me. And these are one of my earlier cases in terms of what I was trying to do to navigate, no pun intended, or how I evolved my thoracic program when I started combining technologies. So this is a 69-year-old male. He was actually the father of one of our intensive care nurses, and he had a history of multiple heart issues, but he ultimately has a history of COPD also. He was a big-time smoker. And again, he was being seen because of the fact that he had this chronic cough and he had the workup, which of course includes a chest x-ray and finally a CT scan. And so this is what the CT scan showed us, and ultimately he ended up with the CT PET scan. So there was a 4-centimeter PET avid lung mass in the right upper lobe. There's no one in this room that's going to deny that this is a lung cancer until proven otherwise. And so this patient needs to not only get a diagnosis, but they need to get staging, and they need to get the proper surgical treatment or medical oncology treatment. But the other issue for this patient was not only did he have this 4-centimeter right upper lobe mass on the left upper lobe, there's also a spiculated lesion that made us kind of think to ourselves, I wonder what's going on here. So I called the interventional radiologist, asked, hey, can you guys try to biopsy this thing? And the biggest reason why they didn't want to biopsy it was because of the fact that, as you can see here, this patient has significant emphysema of the left upper lobe. So therefore, this fits this patient into that category of developing a high rate of a pneumothorax, at which time, if the patient's admitted, then of course he doesn't get his other procedures for his right upper lobe. So they really kind of hemmed and hawed and says, I really not like to do this. Can you do something else? So I was like, well, now I got this new robot in my OR. Let me see what I can do. So this, again, is one of my very first cases. And so I really want to get a crack at, can I get a diagnosis for the right upper lobe lesion? Well, that was a really easy nodule to biopsy. If anyone in this room misses a 4-centimeter lesion on your robotic navigation bronchoscopy, go back, pull out your Nintendo or something like that, and you can start playing those games, because it's really as simple as something like that. But my biggest concern was I going to be accurate enough to really diagnose or to rule out that the patient had a concurrent left upper lobe lung cancer? And in my head, I was like, I did not want to be in that situation again, where I said, hey, you don't have lung cancer. And of course, the patient does on the left side, or I, did it backwards and so on and so forth. So I started coming up with these sort of ideas and how I can actually find this out. So I started doing these navigation bronchoscopy procedures where I started injecting certain dyes into the lung to give me a visual aspect to know what to take out. So I went and marked the left upper lobe, and I did a robotic wedge resection. You can see that, there's your, fancy ICG nodule, and all it is really, as a thoracic surgeon, just like we learned in kindergarten, cut around the corners, cut around the lines, and all I did was cut out all the green stuff. And when we looked underneath the pathologist's slide, we can see that this patient, of course, in the right upper lobe, my biopsies were easily able to confirm squamous cell lung cancer. And my left upper lobe wedge resection at the time showed caseating granuloma, thereby confirming with over an 87% degree of certainty that the frozen pathology showed me no evidence of cancer, at which time the patient now got staged and he had a right upper lobectomy. So that really saved this patient a lot of time in terms of getting that, what we call the ping pong ball effect, right? Usually what happens conventionally, and I'll talk about this in my lecture as well, is these patients get a diagnosis of, a lung nodule. Then they get referred to, I don't know, a pulmonologist or a primary care physician or a medical oncologist, and they say, aha, you need a lung biopsy. And so they go and have to schedule that lung biopsy at interventional radiologist, and that takes about 2 to 3 weeks. They get the lung biopsy. The biopsy takes about a week to get back, and then someone follows up on the data. a week later and says, oh, you have lung cancer, let me refer you to someone else. Sometimes I'll bring them to the office, and it takes 2 or 3 weeks to refer them to someone else. It could be a pulmonologist, medical oncologist, thoracic surgeon, at which time someone says, oh, you need a staging. So they send it to a pulmonologist or a thoracic surgeon to get the endobronchial ultrasound or the mediastinal or the mediastinoscopy. 2 or 3 weeks go by, and they say, oh, you don't have any lymph nodes are positive. Let's send you to a surgeon to do the surgery. So you can see how that poses a significant delay in patient care. And we'll talk about why that's really important here. Just for the sake of time, I don't want to talk about the second case. It's just a case, I'll go really quickly, where IL-1 is used to prove that this nodule in the left upper lobe in a patient with a esophageal cancer was not cancerous, and therefore the patient was able to complete his regimen and get cured from his gastroesophageal junction cancer. So this is where we start to really evolve now, and this is why I start kind of put it all together. And so the real reason, at least in my opinion, that we don't have a very good survival rate for lung cancers because in the past, we really hemmed and hawed and waited for these lung nodules to grow bigger. And that was the biggest problem because we see, for example, as our interventional pulmonologist alluded to, you have a patient with a 3 millimeter lung nodule, smoking history, and this nodule, of course, no one's going to say, hey, let's go and operate on a 3 millimeter lung nodule, but they get entered into a pulmonary nodule program, which means that we say to these patients, yes, we need to make sure the surveillance is done on you, and we'll get a CT scan in 3 months or 6 months, depending upon your degree of risk. So if this 3 millimeter nodule grows to 6 millimeters and is spiculated, it's solid, well, that's a lung cancer until proven otherwise. But in the past, there's a lot of surgeons are hesitant to do an entire lobectomy, where you take out the patient's entire lobe for a 6 millimeter or an 8 millimeter nodule, because what if it was not cancer? Now you've actually not helped the patient out, but now you've opened up a whole can of worms of complications, at which time we did not help this patient at all. So I really want to see what I can do to move that needle, if you will, and do what we call stage shifting. So this is a case of a 54-year-old male who had an incidentally discovered pulmonary nodule in the left lower lobe. The patient never smoked a day in his life. He was actually an athlete. And he got enrolled in a pulmonary nodule program, and then again, we had a repeat CT scan several months later, and we saw that this pulmonary nodule went from 3 millimeters to 7 millimeters, and it became spiculated in morphology. So here's a CT scan. And again, when you look at the CT scan, most of it looks very normal. What we're really focusing on is on this tiny, tiny, tiny nodule in the left lower lobe. Now, the biggest problem about finding these nodules, and I explain to my patients, is very similar to taking 2 grains of rice and putting it in a pillow and saying, aha, now I want you to feel that pillow, that pillow and see if you can find these grains of rice, or if you can look at a pillow and tell me where the grain of rice is. And of course, that is a very daunting procedure, and we're not going to be able to do it. So I started doing, again, in almost standard treatment and protocol for our patients, we started doing these navigation with dye markings where I'm injecting ICG and Omnipaque directly into the nodule, so now I can visually inspect the lung to see where this nodule is. So we went in and I took it out, I did a wedge resection, again, same thing in kindergarten, take all the stuff that looks green, and I walked over to the pathologist and I said, hey, listen, I got this nodule out here, what do you think you see? So this patient, quite honestly, in my mind, had a very low risk of anything real, right? Maybe at most adenocarcinoma in situ. It was at the end of the day. I still remember, it was about 5:30, and our pathologist had the key sign, right? So she was ready to go home, because I remember her daughter had horseback riding lessons, so she was trying to rush out of the hospital to get home in time. So she looked at it underneath the microscope, and she's like, oh yeah, it's adenocarcinoma in situ. So I said, okay, great. Wedge resection, we're done. So I walked out of there, and I walked back to the operating room, and in my operating room, I actually have this, kind of fancy microscope. This fancy microscope is called Van Gogh, and I'll explain it in a second. But what happens, I looked across the room at the Van Gogh, and I saw this. This is actually I saw this image. This image is essentially the virtual imaging of this nodule I took out, and you can see all these big yellow cells that are lighting up because of metabolic activity. So this Van Gogh system was very integral in having me say to myself, oh my God, I really think there's cancer. So I run back to the pathology office, and Rebecca's like literally like kind of leaving. I said, Rebecca, I really think I see cancer here. And so she goes, well, what do you mean? So I explained to her. So she goes back to the slide and she looks and she goes, oh my God, you're right. There is invasive adenocarcinoma on the corner of the slide that I didn't see, and so it really changed the paradigm for this patient. This patient ended up with a segmentectomy and, left 2 days later out of the hospital. And again, this patient has a 90% 5-year survival rate because of the fact that we didn't waste time taking this cancer out. Again, you can see how small these cancers are, how they can be misinterpreted even on the day of surgery by pathologists. And with the advent or the incorporation of certain technologies, we were able to save this patient a second trip to the OR. And again, we potentially save this patient, a stage elevation from, delay in care and so on and so forth. Maybe, maybe not. But ultimately, what this technology is that we use also is called the Van Gogh system, and it's a dynamic. It's a microscope that uses what we call dynamic cell imaging. It's a really cool technology. What it does, it actually measures the vibrational activity of certain cells. And so cancer cells, will have more mitochondrial dependent activity. And so by telling these, by detecting the vibration, it actually gives us sort of this heat map. So now we can see cells that are bigger and larger than normal cells, i.e. cancer cells tend to be larger, pleomorphic, and they tend to stick together, what we call clumping. And then when they light up, you can see that the yellow cells that I showed before. That gives you a very high degree of suspicion that you have cancer cells, at which time you can enact the proper treatment for these patients. Now, this is really why we do all this, because of the fact that truly accelerating the timeline and the efficiency of diagnosing, staging, and treating cancer is what it's all about. And only by succeeding in doing that are we really going to have any impact in saving these patients. But now, if you look at the current guidelines for addressing what the maximal acceptance of waiting time it is, when a patient gets a diagnosis and referred and so on and so forth, if you look back in January, again, this was introduced back in January 15th, they have determined that a maximum total wait time of treatment is 35 to 42 calendar days from referral to the start of treatment, right? So that's a pretty long time. The biggest problem about that is the fact that when you look at cancer doubling time, adenocarcinoma, the tumor doubling time is about 150 days, squamous cell cancer is about 130 days, we don't know where that 35 days to 42 days is in the growth of that cancer. So if we're on the back end of that adenocarcinoma and it's 1 centimeter, and we wait the 3 months to 2 months, getting these patients into the OR, that patient can double that 1 centimeter cancer to 2 centimeters, at which time they go from a stage 1 to a stage 2. The biggest problem about that is when patients have stage 1 lung cancer overall, we're talking about A, B, C, and D, the A, B, and C, the overall 5-year survival rate for lung cancer patients or stage 1 is about 70 to 75%. When they go to stage 2, the overall 5-year survival rate for stage 2 patients is 45%. That's a huge drop in the survivability for these patients because of the fact that we delayed their care. Now, we didn't delay their care because we did anything wrong. I think we delayed their care because we did not have technology that could really help these patients way back then. So hopefully, by moving the needle, and we do this in 3 hours, we can truly help out these patients and really save some lives here. What do? Well, the first thing I did, I said, okay, I really want to kind of give credibility to what we're doing. So I'm a private surgeon. I hate writing papers, right? And so I really sat down because I really thought this was really important. I convinced a medical student to write this paper for me, and we showed, I did pay him, so that's private practice rule, right? But anyway, so we were able to document that it did not matter. In every single case where we intended to get out that nodule, we had a 100% success rate in getting out that nodule to either prove or deny cancer. And this is why it's so important for these patients. The biggest problem, I think, that hinders sort of these patients is there's a certain sort of dialogue that goes on with non-surgical professions. And these guys are saying, well, we saved you from surgery. I think there's a big problem with that. Unless we actually learn to work together with our interventional pulmonologists and medical oncologists, no one's saving these patients from surgery. What we're doing is we are potentially missing lung cancer. Why? When you do a wedge resection on these patients, a surgical wedge resection, that surgery takes us about 15 minutes to do. You take out the nodule, If it's cancer, well, great. If it's not cancer, these patients really stay in the hospital. Sometimes people leave later that afternoon. Some people leave the next day. But the complication rate from a surgical wedge resection is very low. It's less than 1.5%. So we are not saving these patients from surgery. What we're doing is saving them from 5 years of anxiety, wondering if this nodule is truly cancerous or not. But more importantly, if it is cancer, we are saving them from lung cancer. And I think that sort of discussion among the medical community should really kind of veer away from we are saving these patients from surgery. So you can see what happens when we actually combine the technologies of robotic navigation bronchoscopy followed by surgery at the same time. Throughout the years, you can see, for example, in 1 year I did about 60 lobectomies for stage 1. The second year I did another 55 lobectomies for stage 2. By combining these procedures, we're able to more than double the number of stage 1 lung cancers that we resected in our hospital. And that means that's a 200% increase in curing these patients from lung cancer. Because why? Because before this technology, we had just waited. Before this technology, we had just patted the patient on the back and says, I hope it doesn't grow, but come back in 3 months. I hope it doesn't grow, but come back in 6 months. And if it's cancer, if it grows, then of course, then we missed cancer, guys. And I think that's the biggest problem that we have here. So why do I incorporate robotic navigation bronchoscope into our program? Because as we know, lung cancer screening, it does save lives. And again, there's a whole NCI paper on it. But the biggest problem about lung cancer screening is only about 2% of patients in this country are diagnosed with lung cancer via lung cancer screening. As I said, the majority of patients, over 88% of patients, are diagnosed with lung cancer because of an incidentally discovered pulmonary nodule. So this whole push for lung cancer screening is not hitting our community. I don't know why. It could be, access to healthcare. It can be, anxiety for the patient because I just don't want to find out. It could be, a lack of sort of drive from the primary care physicians and saying, hey, you need a lung cancer screening. I don't know what it is, but currently the lung cancer screening program is not effective in finding lung cancers in a patient, and a pulmonary nodule program really is. And so what I really think that we need to use the robotic navigation bronchoscopy system is to decrease the timing and the duration of diagnosis, staging, treatment. And we can all do this if we actually work together on this. Not only the thoracic surgeon, not only the interventional pulmonologist, not only the interventional radiologist. We need to combine our forces like a cardiac program does. The cardiologist and the interventional cardiologist and the cardiac surgeon, they all work together in doing one thing, and that's saving the patient. And until we actually can do this collectively as a hospital system, I don't think we're going to do much in helping these patients. But when we do, we're going to be doing a lot to save these patients. As we know, earlier cancer detection improves survivability. However, I really kind of want to advance this even one step further. It's not lung cancer detection. It's actually lung cancer not lung cancer screening, is lung cancer detection. And there's a difference because what happens in a hospital that only says, oh, you got a nodule, oh my God, the lung nodule is increasing, versus a hospital system that says, oh, you have a lung nodule that's suspicious for cancer, and we are going to do something about this in the next week or two. That is a lung cancer detection program and no longer a lung cancer screening program, and that's what's going to save lives here. This is just a picture of me. I started doing sort of interventional, interventional pulmonology, and I started using photodynamic therapy in combination with ion cases. So, just for the sake of time, I don't want to take over anyone else's time, but this is a patient with a 10-centimeter metastatic melanoma to the right middle lobe. We don't know where his primary is. We checked everywhere, even all the weird spots, the scalp, the eyeballs, the rectum and stuff like that, and we couldn't find where this guy's melanoma came from. But we know that in his middle lobe there was a 10-centimeter biopsy-proven melanoma. So the patient underwent immunotherapy, and the biggest problem with this patient that he did not respond to immunotherapy. Why? Because the PD-L1 receptor status from this patient was very low. So PD-L1, I don't want to get into this right now, it's just a receptor that if you have it, good, immunotherapy works for you. If you don't have it, not so good, immunotherapy doesn't work very well for you. Well, the one thing we know is that photodynamic therapy improves or increases PD-L1 activity in a lot of the pathology specimens that we see. So I thought to myself, hey, as a thoracic surgeon, can I navigate this ion into this 10-centimeter nodule, mass now, stick it with multiple sites of the photodynamic therapy and treat with multiple sites, just, with the commercial you saw, we have that cloud-based technology where I can tag different spots on the cancer, and that's exactly what I did. Within 1 month, this cancer went from 10 centimeters to undetectable on a CT PET scan. I then further took him to surgery, did a middle lobectomy on him, hilar lymph nodes. So he had one hilar lymph node that was positive for metastatic melanoma, and he had residual scarring and stuff that they could not see cancer anymore in the rest of his cells. But again, the patient needed, the metastasectomy to be done. So these are sort of like the things that we really need to push with robotic navigation bronchoscopy. It is no longer a diagnostic tool in the right hands. And sooner or later, hopefully, we can start developing protocols to incorporate, pulse electric field technology, photodynamic therapy, injections of certain viruses that increase radiosensitivity of cancers. That's how we start using this navigation bronchoscopy. It cannot replace a CT-guided biopsy. It has to be a treatment paradigm, which you all can help these patients out. So this, again, is another paper from Canada which demonstrates, well, why is it so important to get these patients to the table, right? And so what you can see here is on the curve on the left side of the screen, the dark line represents the survivability of patients who were diagnosed and treated within 30 days. The lower curve represents patients who had treatment after 30 days of diagnosis. That is a big discrepancy between just 1 month of waiting for these patients. And that is why the drive has to be, as soon as we know this nodule exists, it is a race against time to save this patient. We are no longer going to say, hey, listen, if I saw this nodule increase from 3 millimeters to 8 millimeters, I'm not going to get another CT scan. This patient is in the OR getting this nodule out, and how do we find it? We combine technologies. So this is exactly what I was talking about. It's so important to start understanding that hospitals should not call themselves lung cancer screening programs anymore. It really needs to become a lung cancer detection program. And that's what saves lives. If you look here, this is the graph I was alluding to. If you look on the left side, stage 1 lung cancer patients have about 65% to 70% 5-year survival rate. Stage 2 dropped down to a dismal 45% to 40%. Stage 3A, we're talking about less than 20% to 30%. Stage 4 is really kind of an unsurvivable disease, although now with the advent of immunotherapy, we are seeing timelines extended beyond 5 years. However, when you actually tease out the number of patients in stage 1, you can see you have your different stage 1A, stage 1A2, so it goes on and on. But if we can actually go and cure these patients and treat them in the stage 1A portion of their cancer lifespan, that is a 5-year survival rate of 92%, thereby increasing it from your overall stage 1 survival rate of 65% to 70%. And this is exactly why I think it's so important to pursue this paradigm of treatment and evolve all our cancer programs, because that's the only way we're really going to make a dent in treating and saving these patients. Thank you, everyone, for their attention. I know I spoke really quickly. I just wanted to make sure I respected everyone else's time. Thank you again.
I'll start out. Great presentation, Dr. Tsai. I loved how you think about lung cancer screening and lung cancer detection, and really moving this as a surgeon forward in your practice. And obviously, you're doing a lot of these procedures. My question is, when you see a suspicious lung nodule and you're planning a single anesthesia event, at what point do you believe a negative biopsy, or how often do you see that? Do you versus going just for localization and wedge resection? Because I think the biopsy and the rapid onset testing and things take time. So how do you go about that?
Perfect. So my algorithm is, if a nodule is less than 1 centimeter and is highly suspicious for lung cancer, there's certain things I do. So there are these blood liquid assays that can actually predict the probability that this nodule is cancer. So there's a company, again, not trying to plug in companies here, but Circulogene is a company that I use, and one of their subsidiary companies is called Lung Life AI. And by using certain fish analysis of the patient's blood for certain proteins, it can actually increase or decrease your suspicion that this lung nodule is positive for cancer. It's a very accurate test. It's over 85%, 87% sensitive. And so if a patient with a 6 millimeter nodule, for example, has a high suspicion for lung cancer based upon the Lung Life AI, that patient's going to the OR. If it's a patient with the low risk for lung life AI and it's like a 6 millimeter nodule, yeah, okay, now I feel more comfortable waiting. But again, that doesn't mean this patient falls off the radar. They get their CT scan in 3 months or 6 months, depending upon the morphology of that nodule. And if anything changes with that nodule, I don't care what that lung life AI says. That patient's going to the OR. Now, if it's a nodule that's 1.5 centimeters or greater, and you do your robotic nav bronch, let me take a step back. I have actually shifted all my robotic navigation bronchoscopy cases to my interventional pulmonologist. So in the beginning, I can convince one to do it. In my hospital now, I've convinced 7 pulmonologists to do this with me. So now what it's done is jacked up or skyrocketed the number of interventional pulmonology cases for our hospital. And so these guys have become much better than I have in doing the robotic nav bronch. They understand cone beam CT scan to a much better exponential degree than I ever will understand or ever care to understand. So if these guys have two-in lesion with diagnostic tissue that I see on my Van Gogh system and that doesn't look cancerous, then I'm not doing surgery on these patients. So it really depends upon the tumor appearance and the degree of suspicion for cancer. And quite honestly, also, one more thing that we do is on the day of the surgery, we actually do a CT scan as well. If that CT scan shows that the nodule has gotten smaller or is no longer present, of course, we cancel the surgery because then that's nothing that is going to demonstrate cancer as well. So those are sort of like the algorithms that we do to kind of go to the next step, right? And it's all stepwise pattern in terms of, what the nodule looks like, what the suspicion is based upon certain liquid assays. And of course, same-day CT scans also help guide that algorithm.
Again, Dr. Tsai, outstanding talk, and I want to apologize for the very obnoxious music. Welcome to the French Quarter of New Orleans, Louisiana.
I was trying to talk in cadence to it, so it's like I was trying to rap to it, but it didn't work too well.
Yeah, but I want to compliment you on your comments as it relates to the difference between lung cancer screening and incidental nodules. I wholeheartedly agree that incidental nodules, there's going to have a much greater impact on patient survival, and also the nodule detection to treatment time, the importance of that in survival. And I think it's sometimes difficult to have all of the key stakeholders understand the importance of those two concepts. We've been doing we call it the single anesthesia event. Going back, I think our first case was in 2021. And we have kind of some relatively discrete inclusion criteria. Our cutoff is anything less than 2 centimeters, no history of solid organ malignancy within 5 years of presentation. Do you have any specific inclusion/exclusion criteria on top of what you've already mentioned?
Yeah, so for us, 2 centimeters was actually too big of a nodule to go after. We really want to see if we can push our program to really increase the percentage and yield for stage 1A lung cancers. The biggest problem about 2 centimeters is now you're really walking that sort of gray line between stage 2 and stage 1, right? And so that's our biggest concern is if we started doing things that were easier to hit with the robotic nav bronch on biopsy, then we were very concerned that we were missing those truly, truly early stage lung cancer. So for example, you have a patient with an 8 millimeter ground glass opacity, right? And we all say, oh my God, it's GGO. It could be inflammatory, it can be granulomas, or it could be adenocarcinoma or adenocarcinoma in situ. So of course, we're not going to jump in and go and do a surgery right away. These patients get entered into our pulmonary nodule program, and if there's any change in that GGO, especially with solid components that start to change that, that is an invasive adenocarcinoma until proven otherwise. I just did one the week before I got here. I didn't want to show it because I'm still waiting for the diagnosis, but this is such a subtle GGO that increased in size, and when we took it out, it wasn't a GGO. It was actually a nodule that you can palpate. And so again, these CT scans might sometimes underread what's really going on in the lung. But we took it out because of the fact that it looked like cancer. I did put it on Van Gogh, and Van Gogh really demonstrated large pleomorphic cells. I didn't want to waste it on frozen because it was so small, and the pathologist was like, well, if I do a frozen in this, I might not have enough for NGS and stuff like that. So I said, it's okay. Let me just, so he did a smear. He took and he says, well, we do have really large cells here, but I can't tell you it's definitely cancer, which is fine by me. Whatever it is, we took it out, we went through, and we did the right thing. So I really think that it's imperative that if we want to really do anything about the survivability of lung cancer, we need to push the envelope. And subcentimeter nodules definitely fall in the category of biopsying. And if they can't biopsy accurately with robotic nav bronch, then you better be on standby to take this out as a wedge resection. The thing about it is our pulmonologists are getting so good. These guys are hitting 1,000 cases. When they incorporate cone beam CT scan into the room, they will get tool and lesion. The biggest problem about tool and lesion, that does not necessarily mean you have lesion and tool. And that's the biggest problem about saying, well, my needle's inside the lesion. But that doesn't really necessarily mean you're getting the representative sample of that 7-millimeter nodule, which can demonstrate cancer. And that's why if the suspicion is high enough, I actually don't waste time with the biopsy. I say, hey, get me an ICG dye marking. I'm going to take this thing out. Now I got the whole nodule that I'm bringing to the pathologist, and that gives me a much better representation of his cancer or not. I have not met a patient yet that you took out this nodule and you told him, hey, it's not cancer. I had not had one patient tell me, oh my God, you did unnecessary surgery on them. Every patient will say, thank God you took it out, because now I don't have to be looking over my shoulder for the rest of my life, for the next 5 years, wondering if this is cancer or not. They know it's out, and these guys are the high-risk patients, the big smokers, et cetera, history of cancer in their family. They want this nodule out. And it's the same thing. I don't know of any female that says, well, I have a breast nodule, just leave it in there, let's keep on watching. Every female's like, take out that nodule in case it's cancer. Why? Because the surgery is so minuscule for taking out that nodule in the breast. We need to start believing that the improvement in robotic surgery makes the wedge resection that minimally invasive that these patients will also have no problems taking out a nodule that's not cancerous.
I want to clarify, 2 centimeters was our upper limit. Anything above that.
Okay.
Really look at things smaller.
Yes, sir. Sorry, I misunderstood.
Thank you, Dr. Sai.
Thank you, everyone.
Good job. Nope. I'm not really sure. Okay. All right. Thank you very much, Dr. Sai, and kudos to you for navigating the sirens and bounce music. That was impressive. All right. Here we see. All right. So next up, we're gonna shift from the surgical perspective. We talked about diagnosis. We talked about combined diagnosis and surgery. We talked about the importance of why that's allowing us to catch things at an early stage, and the potential conflict or the potential complication of upstaging if we don't catch it at an early stage. So what happens when they get upstaged? That's when we turn to our faithful medical oncology colleagues. So the next talk is going to be by Dr. Millett. He's a thoracic oncologist at Ochsner. He trained at the University of Cincinnati, where he did his residency at George Washington, where he was the chief resident, and then went on to do his fellowship at Emory. He is an accomplished researcher. He's won the ASCO Cancer Young Investigator Award for his work in immunotherapy, and we know him very well from teaching us in our tumor board, and he's a brilliant mind and a really valuable tool to the thoracic oncology program, and he's teaching us on a regular basis, so I'm excited to have him teach us here today.
Alrighty. All right, good afternoon, everybody. My name is Linwood Millett. Like Dr. Dozier said, I am one of the thoracic medical oncologists in New Orleans here at Ochsner, MD Anderson Cancer Center. I have a small disclaimer. My pictures and lack of videos are going to seem a little more boring than the presentations prior, but I promise that they are important, and if you turn your head just right, they might also look exciting. Here are my other disclosures. So last year at CAGLA, I gave a general overview of systemic therapy options in resectable non-small cell lung cancer. Even since that time, there have been a number of updates. I'd like to review those today. I also want to expand a little bit to include non-resectable but still early stage disease, incorporating radiation as a modality. It's a pretty big topic. Certainly can't do it justice, so I'll try to hit the highlights. I'm going to organize it first by resectable and then unresectable disease, and then also by treatment type, so immunotherapy and then targeted therapy. So we'll start with updates in resectable non-small cell lung cancer. As has been discussed, the ultimate aim of surgical treatment is cure. We know that a proportion of patients will be cured with surgery alone, but that amount or that percentage of patients decreases with increasing stage. In order to improve the chance of cure, we can tack on systemic therapies. We can do it in a number of ways, either after surgery with adjuvant systemic therapy, prior to with neoadjuvant therapy, or on either side of surgery with perioperative therapy. Last year when I gave this talk, this was the landscape. And you can see even since 2021, we've had kind of an explosion of treatment options. This has increased even more, which is very fortunate for our patients, though perhaps less so for us, as it makes it a very complicated field to wade through. And it requires that we make nuanced considerations on a patient-by-patient basis. Before I talk about any new studies, I do want to update some of the older studies. First, we'll start with Checkmate 816. So this was the first approved regimen using neoadjuvant chemoimmunotherapy in this setting. These updates that I'm about to go over were first discussed at ASCO 2025. So the study looked at upfront chemotherapy plus or minus immunotherapy with nivolumab for 3 cycles, followed by surgical resection. Patients had to be stage 1B through 3A, noting that this was the 7th edition AJCC staging criteria, so 4 centimeters or greater or no positive disease. Primary endpoints were pathologic complete response and event-free survival. And I think in many ways, as many people here can probably attest, this did kind of upend the way that we practice with early stage disease. Previously, we chiefly reached for adjuvant chemotherapy alone. I think there were initially concerns about what this meant for surgery, where fewer people are going to make it to surgery, where surgery is going to be more challenging due to treatment effects from the immunotherapy. But I think all the evidence points to the fact that both improved surgical outcomes and overall outcomes indicate that this is the new standard of care. So we did previously have good 2-year event-free survival data, and now we have the 5-year overall survival data to further support the use of neoadjuvant chemoimmunotherapy. So there's a statistically significant difference in 5-year overall survival with a median 5-year OS of 65.4 months in the Nivo arm versus 55 months in those who did not receive nivolumab. As with the original publication, this update does demonstrate variable efficacy based on stage as well as PD-L1 expression. As you can see here, the trend towards greater benefit is in patients with higher disease, noting that there's just clearly a greater separation in the curves with patients who had stage 3A disease. In both, the confidence intervals do cross 1, but it does so to a lesser degree in the higher stage disease. Likewise, results varied by PD-L1 expression. In patients with PD-L1 negative disease, the median OS wasn't reached, but if you look at the percentages between the Nivo and the non-Nivo arm, they're pretty much the same at 53 and 52.6% respectively. In the PD-L1 positive groups, however, those numbers are significantly different. 78.3% in patients of patients are still alive at 5 years who received nivolumab versus only 57.6% in those who did not. So here is an important exploratory analysis, which is going to be mirrored by the other studies as well. We can see that there's a clear survival benefit in patients who achieved pathologic complete response. There's a really impressive hazard ratio of 0.11. This is compared to patients who did not achieve a pathologic complete response. This is an almost 90% reduction in death at 5 years, which is just a phenomenal number. There was also a trend towards improvement in overall survival in patients who cleared circulating tumor DNA as tested by a number of molecular residual disease tests. This is a really important consideration, recognizing that all comers actually benefit. So you could certainly make the case that people who are PD-L1 negative or are lower stage may not benefit as much, but we can actually see that regardless of stage, regardless of PD-L1 expression, there is a chance for pathologic complete response, and people who are PD-L1 negative or low stage and had a path CR are still alive at 5 years. In my mind, I think that this really, it means that we should consider anyone who's a worthwhile candidate, or we should consider this worthwhile for anyone who's a candidate, really. I also think it's worth remembering that PD-L1, while helpful, is an imperfect biomarker, so we need to make these decisions in a broader context alongside the patients. So how does this impact practice? Well, I think it certainly reinforces that neoadjuvant chemoimmunotherapy is and should remain a mainstay of therapy in patients who qualify. That said, great update for Checkmate 816, but we are still faced with a big question: in whom should we use perioperative chemoimmunotherapy, and in whom is neoadjuvant alone sufficient? So this past year, we did receive updates in all 3 major perioperative regimens, the schema for which you can see here. The study designs are all quite similar, varying only by type of immunotherapy and type of platinum, as well as frequency of immunotherapy administration. In all of these, patients received chemoimmunotherapy up front, then surgery, and then 1 year of immunotherapy subsequently. So we'll look first at Checkmate 77T, which is an update to nivolumab, so kind of the inheritor of Checkmate 816. Previously published data were 18-month EFS, and it favored certainly perioperative Nivo over neoadjuvant chemotherapy alone. Updates from ASCO show us both EFS and OS data now at 30 months. EFS is still significantly improved at 61% in the Nivo arm versus 43% in the chemo-only arm. And there's a corresponding trend, at least, towards improvement in 30-month overall survival. Importantly, this is kind of reflected across all analyzable subgroups, and there are no new safety signals at this time point. Now, going back to this pathologic complete response thing, and also circulating tumor DNA. The presence of both of those things portends improved outcomes, as has been shown in other studies. This is, I think, not unexpected, but it was overwhelmingly the case that patients who did not attain circulating tumor DNA clearance likewise did not achieve a pathologic complete response because there was still tumor left behind, and that just makes sense intuitively. We also see in the study that event-free survival favored Nivo irrespective of some of the bad actor mutations that we like to bandy about in tumor board, KRAS, KEAP1, and STK11. Moving on to durvalumab in the Aegean trial, updates here were provided on exploratory analyses looking at post-surgical clearance of circulating tumor DNA yet again, and then the outcomes thereof. In previous publications, it has been shown that circulating tumor DNA clearance following neoadjuvant treatment correlates with improved pathologic complete response, event-free survival, and overall survival. So looking at the updated information, it is perhaps unsurprising that patients who had molecular residual disease after surgery were those who had higher stage disease, as well as circulating tumor DNA at time of diagnosis. As with Checkmate 77T, no MRD positive patients, when I say MRD, I mean molecular residual disease, so circulating tumor DNA presence, had pathologic complete responses or even a major pathologic response, which is defined as 10% or less viable tumor at the time of surgery. While patients who had molecular residual disease were in the minority at about 10%, they did account for an outsized share of patients who relapsed or died within 1 year at 42%. This is likewise demonstrated in the 12-month disease-free survival data. So if you have persistent tumor, that is bad. Of note, authors also presented data indicating that KMT2C and KEAP1 mutated disease were more likely to be MRD positive against some bad actor mutations. There did not appear to be an EFS benefit. It was a small number of participants, but it may be a group of patients in whom perioperative durvalumab does not improve outcomes. And then looking at the third with pembrolizumab, we've got Keynote 671. We previously knew 2-year EFS data, which demonstrated a superiority of perioperative pembrolizumab compared to neoadjuvant chemotherapy alone. We got updates from ESMO 2025. We now have 5-year EFS and OS data. So EFS remains significantly improved with an EFS of 50% in the pembro arm versus 26.5% in the chemo arm. There's a corresponding improvement in 5-year overall survival as well, 64.6% versus 53.6%. And notably, this is the first perioperative immunotherapy trial that does have positive 5-year overall survival data. This is very important data. Also importantly, outcomes were improved pretty much across all groups, and again, no new safety signals. So of all these regimens, the question is, when do we use what? I don't know. There haven't been head-to-head evaluations of neoadjuvant, perioperative, or adjuvant treatment regimens. In my mind, at least, I think that the case is strong to incorporate neoadjuvant immunotherapy at the very least. It allows for improved priming of T cells against a larger array of tumor neoantigens. The T cells are able to move unhindered or less hindered through a largely undisturbed lymphatic system. And you also can avoid a post-surgical gluconeocorticoid surge, which may hamper immunotherapy effectiveness. But what patients benefit from the addition of adjuvant therapy immunotherapy beyond the neoadjuvant chemoimmunotherapy. As you can see in this little cartoon, activated T cells do persist after neoadjuvant immunotherapy and surgery. So how much more immunotherapy, if any, is going to benefit patients? We have to recognize that immunotherapy is not a benign treatment. Ongoing receipt of immunotherapy increases the risk of immune-related adverse event at any point on time on trial or on treatment, as well as for months afterwards. So we really should pin down what patients are going to benefit the most from extra immunotherapy. It's a big question, and I don't think it's been answered yet. Should patients who have viable tumor at the time of surgery receive more immunotherapy? Do patients who have viable tumor at the time of surgery, are they more refractory to immunotherapy and therefore won't benefit? Should it be patients who have circulating tumor DNA? We don't know. So, major caveat that with cross-trial analyses comes a lot of peril, so don't stone me. But when we look at outcomes between Checkmate 816 and some of the perioperative trials, the outcomes do appear relatively similar. There are no prospective studies currently comparing these two options, but there have been some meta-analyses performed. They have failed to demonstrate benefit to adding adjuvant immunotherapy to neoadjuvant chemoimmunotherapy. In one looking at 11 randomized controlled trials with over 4,500 patients, there was no improvement to EFS or OS with the addition of postoperative immunotherapy. There's another looking at 5 randomized controlled trials, same outcome. So I think while updates over the past year provide us with data upon which to build, at present, I don't think there's a clear answer to the question, and future studies will need to be performed in order to better answer it. Some of these are ongoing, and they seek to offer novel upfront combinations with the goal of increasing pathologic complete response rates as well as circulating tumor DNA clearance. In my personal practice, I still tend to reach for neoadjuvant chemotherapy alone, given that it has good outcomes, decreased costs, and decreased burden of treatment on patients by foregoing a year of extra immunotherapy. That said, I do think perioperative regimens are a very appropriate choice as well, and we haven't even discussed adjuvant regimens, which we're not going to discuss, because there are no updates. So now that that isn't settled, I'd also like to draw attention to emerging data that indicate that the time of day during which patients receive immunotherapy might actually significantly impact outcomes. So the LungTime CO1, it was a randomized phase 3 prospective trial evaluating efficacy of immunotherapy when delivered either prior to or after 3 p.m. in the day. Randomizing 210 patients to either time block, both PFS and OS are significantly improved by earlier administration of immunotherapy, with a PFS of 11.3 months versus 5.7 months, and an OS of 28 months versus 16.8 months. This is a big difference. I think this has also been mirrored in other studies. There's the Minmar study looking at melanoma, which showed the same. There's a meta-analysis of 18 other studies with various tumor types, and that meta-analysis indicates that earlier time of day infusions could enhance PFS and OS up to 4-fold. This is, of course, it has administrative implications, scheduling, et cetera, but I do think that it's sufficiently compelling to impact practice. So moving away from immunotherapy at breakneck pace, we will discuss targeted therapy. So I don't want to start anything new. We'll just kind of rehash ADORA real fast. This was a trial that evaluated adjuvant osimertinib, which is a once-daily oral TKI for EGFR mutated disease, in patients who had a tumor of at least 4 centimeters in diameter, with or without, or with lymph node involvement. Patients had to have an exon 19 deletion or an L858R mutation. Patients could receive standard adjuvant chemotherapy before the OC, and ultimately receive 3 years of pill. This trial had some really impressive data. These are some good curves. As you can see here, DFS was not met at any stage of disease treated, and importantly, this includes stage 1B disease. Remember that in like 4 slides. So one of the new trials being discussed today is NeoADORA, which seeks to prove if there is utility in a perioperative or at least a neoadjuvant approach with osimertinib as opposed to a purely adjuvant approach. This was a phase 3 trial. It looked at 9 weeks of OC up front in patients who had completely resectable EGFR mutated disease. It had an interesting primary endpoint of major pathologic response, not pathologic complete response. There were 3 arms here, so OC plus platinum and pemetrexed, OC monotherapy, and chemo alone. Notably, and this is notable, patients were allowed to receive adjuvant therapy, including osimertinib, and in fact, 91% of patients did. So this is really important to remember with the data. So looking at major pathologic response, there is a clear superiority in both of the osimertinib-containing arms, with a major path response of 26% in OC chemo, 25% in OC alone, and a measly 2% in chemo. Importantly, this superiority appears maintained across all evaluable subgroups, irrespective of EGFR mutation type, smoking history, baseline circulating tumor DNA, and stage. The authors also presented EFS data. It's only 15% mature, at least when this was presented, but EFS rates at 12 months were 93% for OC chemo, 95% for OC alone, 83% for chemo, and so it again favors the osimertinib-containing arms. So whereas in many trials, pathologic complete response was either a primary or a secondary endpoint in NeoAdora, the trial was designed to detect major pathologic complete responses, again defined as 10% or less viable tumor at the time of surgery. Pathologic complete response has proven its utility when examining immunotherapy, but the utility, I think, in TKI studies is not been made entirely clear. I do think, in this trial, it's important to note that MPR status does appear to correlate with EFS based on the EFS analysis, the interim analysis. It's also worth remembering that pathologic responses exist on a spectrum. In the aforementioned immunotherapy studies, there are trends towards improvements in patients who had a major path response, if not a pathologic complete response. So besides adding yet another tool in our already considerable armamentarium, how do these results impact practice? First, it is important to note that this regimen has not been FDA approved, but I assume that it will be soon. So a case can be made for using this regimen in patients who have bulkier disease, recognizing increased chance for micrometastatic disease that could blossom after surgery. Also worth noting is that there is a significant proportion of patients who had nodal downstaging at the time of surgery. It has generally been the case that with neoadjuvant regimens, we are selecting for patients who are resectable at time of diagnosis, and we are not using medicines to downstage. However, in this case, it's something that we may actually consider. I think it's also, or finally, when comparing the rates of major path response and early EFS between the two OC arms, the outcomes are pretty similar. The question is, do the patients really need platinum doublet therapy with the OC or not? I think more mature data will be interesting. Now, another ADAURA variant, this is ADAURA 2. It's an ongoing phase 3 evaluating use of adjuvant osimertinib in even earlier stage disease. So remember, with ADAURA, there was benefit as low as 1B. So now we're looking at 1A2 and 1A3. We don't have any data yet available for this, but if positive, again, I think it will shift paradigm. Moving from ALK-rearranged disease is the ALNEO trial. Now, this was a phase 2 clinical trial looking at perioperative alectinib in patients who had resectable stage 3 ALK-rearranged non-small cell lung cancer. Patients received the equivalent amount of alectinib as they would per the ALINA trial, which is purely adjuvant alectinib. And they did this for 2 years after surgery. Again, primary endpoint here was major pathologic response. As with ALINA, and unlike the EGFR studies, there was no option for systemic chemotherapy in this study. With a major path response of 42%, so the trial did meet its primary endpoint. Other notable results, a path CR of 12% and an overall response rate of 67%. Those were secondary objectives. And median event-free survival and overall survival were not reached. So as with NeoAdora, this is not FDA approved. As with NeoAdora as well, it's unclear who might benefit, that we can consider the same scenario of bulky disease for the same reasons. I think an interesting question, both with ALINA and ALNEO, is whether alectinib is even the right drug. Now, there is no data yet on the use of lorlatinib in resectable disease, but the CROWN data is just so impressive, I can't help but to wonder if it will make its way on the stage soon. I'm almost done, I promise. So moving away from resectable disease, we're going to go to the still early stage, but now unresectable disease. So recognizing that immunotherapy improves PFS and OS in operable early stage non-small cell lung cancer, SWOG NRG S1914 looked to determine the utility of immunotherapy in patients receiving SBRT. So randomized phase 3 in which patients received atezolizumab in advance of, during, and after radiation therapy. Eligible patients had to have no negative disease, less than 7 meters in size, and they had to be deemed either medically inoperable or they had to have turned down surgery. Notably, the trial did enrich for high-risk features, including tumor diameter of at least 2 centimeters, an SUV of 6.2 on PET, and moderately or poorly differentiated histology. Ultimately, this was a negative trial. It closed at the first interim analysis due to futility, both for progression-free survival as well as overall survival. There were also more grade 3 or higher adverse events reported in the combination arm. Interestingly, there appeared to actually be a worse PFS in the immunotherapy arm than in the radiation arm. During the panel discussion at ASCO, it was posited that this may have been to overreading fibrosis from the radiation as actual progression. These outcomes are actually similar to another phase 3 clinical trial. It was Keynote 867, which looked at a similar patient population. It likewise did not improve EFS or OS, but it did increase toxicity. So based on these outcomes, at least for now, I think it's unlikely that we'll be using immunotherapy in advance of SBRT or with SBRT in early stage disease. I think it also proves that SBRT is pretty effective and it sets a high standard. I think another question this raises is how much stock should we put into the abscopal effect? Despite thoughts that radiation therapy might expose the immune system to a greater array of tumor neoantigens, I think there have been a lot of studies that have kind of maybe indicated that this is not happening. What this means more broadly, I can't say. I do think it makes me question whether this is an effect we should actually consider or not when we're determining how we're going to treat patients. But what about higher stage, non-resectable, but still not metastatic disease? So standard of care for stage 3 unresectable non-small cell lung cancer is the PACIFIC, assuming there are no actionable genomic alterations, with concurrent chemotherapy, radiation therapy, followed by immunotherapy with durvalumab. The INTEREST study wanted to see whether the addition of induction immunotherapy may improve outcomes in bulky stage 3 disease. This was a phase 2 randomized clinical trial. It evaluated 2 cycles of induction chemotherapy and immunotherapy versus induction chemotherapy alone in advance of CRT followed by consolidative immunotherapy. Of note, it does use toripalimab instead of durvalumab. It is a Chinese study, and when it opened, durvalumab was not readily available in the market, but relatively similar. Eligible patients had to have bulky stage 3 disease, so either 5 centimeter tumors or larger, or nodal size of at least 2 centimeters. Primary endpoint here was PFS. Median PFS was not reached in the toripalimab arm. It was 12.4 months in the chemo-only arm. Overall response rate was 77.8% versus 40%. Importantly, there were higher rates of grade 3 pneumonitis with the induction immunotherapy at about 11% versus 4%. Where I practice, we do sometimes utilize upfront induction therapy for very bulky disease in advance of chemoradiation in the hopes of making the disease more amenable to radiation therapy. And we will often utilize immunotherapy as part of that regimen as best systemic therapy. When we do so, it's always a topic of conversation at our tumor board, recognizing the theoretically increased risk of pneumonitis. I think this trial not only indicates that it might be a safe maneuver, but also an effective one, recognizing that it's only a phase 2, and it does use a drug not typically used in the US for this purpose. So, key takeaways. Neoadjuvant chemo IO improves 5-year overall survival, so does perioperative. Who knows which is better? Neoadjuvant targeted therapies are an emerging option. Immunotherapy is unlikely to improve outcomes when SBRT alone is indicated, and there is room for improving systemic therapy options in stage 3 unresectable non-small cell lung cancer. Dean.
Questions? All right.
Thank you. So thank you so much. Neoadjuvant therapy is out of the bag now. And one of the challenges that we had when it first started, and I'm glad I have some surgeons here, is we still have between 17% of patients and maybe 18% of patients in most trials not going for curative intent surgery. And so we're seeing a 10% overall survival with the addition of immunotherapy to chemotherapy, but we're seeing 17% of patients not making it to the operating room. And so I think the question as we adopt neoadjuvant therapy is always that challenge, making sure that those patients are ready. And I'm actually glad you presented the data at the end, because my question isn't whether or not we're doing neoadjuvant therapy, because I think the long-term benefit with these patients and us talking about doubling time for these cancers and saying get systemic therapy in because we know they're failing distant right now anyway, is the patients that we can't take to the OR, we're flipping to radiation. And you answered the question that I had at the end. So when you have that neoadjuvant patient that's failed, are you bringing it back to tumor board and discussing then jumping in with radiation with those patients then and then kind of flipping them?
Yeah, that's a really good question, and another one I don't think is well answered. So we do tend to do that. It has not, fortunately, been an incredibly common occurrence, but there are patients who, after 3 or 4 cycles, are progressing. If it's local, we have taken them to actually CRT followed by immunotherapy. The issue with that, of course, is that you're exposing to more chemotherapy on top of already having received pretty good doses with the neoadjuvant regimen. If they're failing more distantly, then we generally are not adding radiation and we're just doing systemic alone.
Any other questions? No?
I'll try to jump in that discussion. It's a great question. You kind of distinguished in your talk resectable and unresectable. And as surgeons, that for us is kind of the main questions, and we drive our decisions based on different factors. But in your practice now with the advent of immunotherapy, how do you think that has changed? We're seeing in our practice that a lot of patients that we wouldn't have considered for surgery, potential candidates, and we're seeing patients with lymph node disease, clearing the lymph node disease and so forth. Where do you think this is going to end up, and should we give everybody immunotherapy and chemotherapy to start if they're candidates?
Yeah, it's a great question. So the original trials, again, were not designed to downstage. Patients were enrolled only if they had resectable disease at time of diagnosis. So we don't have good data for that. And that's why I say with NeoAdora and ALNEO, it's an interesting case because there was a lot of nodal downstaging in NeoAdora, at least. Where I am at Ochsner, we present pretty much every patient that we're considering giving any kind of neoadjuvant therapy to at our tumor board with our surgeons present. I don't, Dr. Pettiford or Dr. Dozier, I'm not sure that we ever really have treated anybody with the intent of decreasing unresectable disease to resectable disease. Is that fair? Yeah. Yeah. Now, if that's a future option, I think for sure, but it's not something that we've been doing.
Dr. Miller, great talk. And actually, you didn't sound like Charlie Brown's teacher like you normally do in tumor board with all of these fancy terms. But you had mentioned neoadjuvant therapy for stage 1A disease. How do you present that to patients and get buy-in from patients? Even, for example, based upon the ADAURA trial, I would talk with patients with stage 1B disease about adjuvant Tagrisso, and sometimes even that is a tough sell. So how do you convince a patient to get neoadjuvant treatment with clinical stage 1A disease?
So we're offering stage 1. So the way that I practice, again, it's based off of kind of the metrics in the study. So if someone has 4 centimeters or greater tumor or node positive disease, I will offer them immunotherapy. If they have a stage 1B, I won't. So stage 1A, I say surgery. I don't do any kind of medicines in that situation. Now, in the lower stage disease, I do try to have an informed and non-Charlie Brown conversation with them to discuss, the data is not as good. The benefit seems to be driven by people with larger disease or node positive disease, and that's not you. But you have some high-risk features, spread through air spaces, VPI, et cetera. And I discussed with them that, we think that we cut everything out. And we hope that we cut everything out. Not we, you. I can't cut a steak. But we say there is a risk of micrometastatic disease. There could be microscopic cancer that our scans can't pick up. And I am concerned because of these reasons that could be in you. And there are patients who turn it down, but it tends to be the majority actually go with it.
Any other questions? Great talk. Thank you. All right. All right, great talk, Dr. Millett. Appreciate it. So the next talk is going to be from Dr. Newartz. So this is Dr. Newartz comes from Ohio State, was one of my bosses there at Ohio State, taught me everything that I know. So it's really special to have him here. Dr. Newartz is the epitome of a surgeon scientist, a fantastic surgeon. He's published well over 100 publications, well over 40, I think, presentations and abstracts. So he's really just a model surgeon scientist. We're really lucky to have him here today. And he's going to talk about putting everything together, surgery combined with immunotherapy. We touched on it a little bit about outcomes following with surgery following chemo IO. And so that's what he's going to be talking about today. Really looking forward to it. Thanks, Doctor.
Thank you very much, Dr. Dozier. We are super proud of you and love what you're doing here at CAGLA. I want to thank you, first of all, for the invitation to come down here to talk. It's been a great time. I love the patient advocacy component and really have enjoyed the conference. So my talk today is on surgery after chemoimmunotherapy, and I want to kind of bring us back home, round it up, and I do realize it's the last presentation of this conference, so I'll try to keep things stimulating for you. I do have to make a disclosure. I do work for I do present a lot on robotic surgery, and I do work quite closely with Intuitive Surgical, who's the company that makes the Da Vinci robot that I'll be talking about. So in my talk today, I want to give you the surgical perspective. You heard the medical oncology perspective and all the different trials that have shown efficacy in the space for early stage lung cancer. And I want to share some of the immunotherapy trials from a different perspective of a surgeon, but also show you real world data, how we are doing things, the outcomes that we're achieving, because it's a little different than the clinical trials. I want to talk about how we optimize outcomes for our patients, and most importantly, what are the long-term prognoses. I want to start with a case. This is a patient that really stuck with me, and this was the early days of immunotherapy. So a young lady, 48, was a never smoker, presented to us with shortness of breath, palpitation. She was in shock, and was found to have a pericardial tamponade, so a malignant pericardial effusion from lung cancer that had accumulated fluid around her heart, and she was in distress. She needed a pericardial window. That's how I met her in the emergency room. We took her to the operating room. We drained the fluid around the heart, and she felt better. And unfortunately, the pathology came back as metastatic lung cancer, non-small cell. This is a very sad moment for that lady because when we typically see this, normally the life expectancy for such a patient would be around 3 months. As a young lady, she had kids, no risk factors. This is a tragedy. And so she recovered fine and was staged. It was quite ugly. The PET scan showed multiple other sites. She had osseous metastasis in her spine. She had a brain tumor. And a bulky lung tumor that you can see here on the CT scan. So she then went on to therapy, first starting with brain treatment. She got that radiated with stereotactic radiation, and then went on to receive chemo and immunotherapy combination. And this was according to some of the early trials in the space that we started in the advanced lung cancer. And she responded. So I was perplexed when I saw her back over a year later. She showed in my office, up in my office, and she was doing well. She had responded and had still a lung tumor, but essentially all the tumor had melted away. So there was no detectable cancer in the spine. There was still some lytic lesion, but all the cancer was gone. The tumor in the lung here, you can see, has shrunk, and we can still see something on the PET scan. There's still a hypometabolic spot there on the bottom left. You can see it. That's the primer side of the cancer. And she said, okay, well, now take it out. And, that I was not convinced that that would be the right thing to do. So I biopsied this lesion, got nothing. And then we observed her, but she did present with hemoptysis, actually massive hemoptysis, came to the hospital coughing up blood, actually arrested from that. We had to bring her back and said, okay, well, we're taking it out now. So we did the operation. It was during the time we were still doing bat surgery. It was a difficult operation. We did a lower lobectomy, got her through, but there was no cancer left in that specimen. So this was a scar, inflammatory nodule in the primary tumor after immunotherapy, complete pathologic response. And this is now over 6 years ago, and we're still in contact. She's doing well. She's without evidence of disease. And this is, I think, maybe illustrative of the effect that this can have. And this is obviously an extreme example, but I can't underemphasize what a difference this type of therapy is making to our patients. So in the early stage lung cancer space, we started with immunotherapy kind of slowly, I would say. At Ohio State, we participated in the LCMC3 study, which was still a phase 2 trial, and we only give immunotherapy, atezolizumab. And we saw responses. They weren't as good as you heard before, but the 3-year overall survival was 80%. For stage 1 to 2 and 3 lung cancer, that's quite good. So that was encouraging. But what we're seeing really is the combination of chemotherapy and immunotherapy that has made the difference. Other phase 2 trials may be smaller and larger confidence intervals, but showing really large or much higher response rates, major pathologic response over 40, sometimes 50%, complete pathologic response over 20%, upwards of 30. That is convincing. So really, really good results. On the other hand, from a surgical perspective, we're seeing that in these studies, patients were operated on with open surgery. So a thoracotomy is a cut between the ribs. We spread the ribs, we open up the chest. The lung and the chest are exposed to air for hours at a time, potentially. There's quite a bit of bleeding sometimes. And this is not typically what we do in the early stage lung cancer field. We have moved past that with our minimal invasive techniques nowadays. So there is a discrepancy in this. But as you heard from Dr. Millett, this obviously is very effective therapy, and we're seeing improvement in prognosis. Now, these are just some Kaplan-Meier curves. I'd love to see separation of the curves, comparison now to chemotherapy alone, which was previously one of the standard treatments for these patients, drastic improvements in the first event-free survival and then overall survival. So, great. We heard from Dr. Millett. This is working. It's great. Major pathologic response, improved prognosis. We're giving it. And then, the surgeon is like, yeah, it's working, but yes, we also see the side effects in the lung. So myelofibrosis, pneumonitis, you saw that tumor that bled. It was just a big inflammatory nodule. It can really make the operation much more difficult. So how do we deal with that? Thankfully, we have the robotic surgery, which is a great tool. Dr. Tsai mentioned it. It really reduces even smaller procedures. The morbidity is reduced, but it really allows us to do much more minimal invasively. So we can do a really good job with the mediastinal lymph node dissection. Even after pre-treatment, we can expose the lung from different areas. And I'll show you some videos. We have 3 times magnified vision. So essentially, it's like wearing loops in the operating room. We see every structure in great detail, and we have very safe energy tools that we can dissect the lung. So here's a video. I'm hoping this displays. Is a patient with stage 2 lung cancer. We're in the right upper lobe and the upper hilum. And you can see on the PET scan above the hilum here, there was a big, fairly bulky lymph node. We call that station 10. And the patient had responded quite well to chemo and immunotherapy. And now we're dealing with this node that's really scarred. You saw us trying to peel it off the pulmonary artery. But we can see that this is very safe. There's no blood loss here. We're doing everything in a very controlled fashion. And this is the main pulmonary artery we're seeing on the bottom. So if there's a hole in there, the patient bleeds very fast and can die from that injury. Another example here, a patient had a left upper lobe tumor treated with Pembro chemotherapy and had a very bad pneumonitis. We were scraping things off the chest wall. We use monopolar cautery. We can take all these adhesions down. And the surgeons will appreciate here how the hilum is very fibrotic, so technical pearls that help us do this safely is dividing all the structures that are accessible to us, opening the hilum. We're getting proximal vascular control on these tumors, and ultimately we can do this safely. In the interest of time, I may skip forward a little bit. So here we're getting around the. Well, okay, well. All right, that's all we're going to see of this video. Anyways, so we did the lobectomy, and it was the 3-hour operations. We're working hard for it, but we got it out, and I'll show you what that means in terms of how that translates into outcomes. So what we're doing, what you saw on the table, over 50% in clinical trials, the majority of patients having open operations, and you have to say in studies in general, anybody is very conservative in patient selection and the approach, and you want to make sure everything goes well, so you're more traditional in a way. But what we're seeing in our practice is that, yeah, we can really be successful here with minimally invasive surgery in this space. And we put a few centers together. This is retrospective studies, so nothing like the clinical trials. Selected patients that underwent surgery. The patients that progressed did not obviously get captured here. These are the patients that did respond or had stable disease that we took to the operating room. But we had over 200 patients, and what we're seeing is that, yeah, the immunotherapy checkpoint inhibitors that were given reflects our practice, mostly nivolumab, because that's how we started. After the CheckMate 816, we got the pembrolizumab as the next drug approved, and we're using that as well. And really, what this main finding is that most patients can undergo minimally invasive surgery. Over 72% had a complete minimally invasive surgery. The conversion rate from that we thought patients could have minimally invasive surgery that we had to open is fairly low, and but we still need to open surgery in about 20% of patients. So you cannot underestimate sometimes the difficulty of the surgery. But every patient is not the same. So although they getting the same medication, the tumor, the location, the involvement of the hilum is very different. So we're trying to tease out how can we predict that? How can we predict which patients do better, which are candidates for minimally invasive surgery? And we analyze it by response of the tumor after the treatment. So we're seeing that in a pathologic complete response, so there's no viable tumor left. There may still be scar, but no viable tumor. Almost everybody, over 90% of patients can have a minimally invasive surgery. With smaller residual tumors, T1, T2, that was like 75%. But if there's still big tumors, T3, T4, we're looking at 50% thoracotomy rate. And this is important when we have these discussions. Patients have this treatment, they may be a higher risk, still have a bulky tumor. What are we going to do? We're going to offer them a big surgery, take that risk, go the radiation route. These are things that help us figuring out what to do with those patients. Other things that we analyzed, factors that are associated with successful minimally invasive surgery were lower SUV max on the initial staging PET scan. So the lower the SUV max, the better it is for the patients in terms of success with minimally invasive surgery. But here in comparison, I wanted to show our results versus what we saw in those phase 3 clinical trials. Our real world data were really better than, consistently better than the clinical trials. And so this is what we're using to tell patients. This is the expectations, I think, that we need to set. The complete pathologic response, again, this is patients that we selected. We're more likely to select patients with higher PD-L1. We kind of have a feeling, and our medical oncologists are very good about they have a competition on who can get most of the complete pathologic response. I mean, they're very good at selecting the patient, so close to 40%. R0 resection rate, and if you look in the clinical trials, it's actually not that great, 80% complete resection. That means you're leaving microscopic tumor behind. That's not good. Our results were 96%. I think that is acceptable, that is good. Pneumonectomy, that is not a good operation. After chemotherapy and immunotherapy, it is possible, but very selective. It is a disease on its own, removing somebody's whole lung on one side, especially on the right. So oral rates for pneumonectomy were lower. Rate of minimum invasive surgery to start out was 72%, completed in over 70%. Just maybe illustrating how the robotics platform helps us. We compared the patients that had robotic approach as well as the more traditional video-assisted thoracic surgery approach with the rigid instruments that we're manipulating at the bedside. You can first of all see from the numbers, most people chose the robotic surgery for this setting. But even with the small numbers, we're already seeing differences. Most importantly, the conversion rate. Again, starting minimal invasive and then having to convert, ending up with an open operation anyways, that's what we're trying to prevent, was less than 5% with robotic surgery and then over 30% with the VATS. The outcomes are fairly normal, but on the top also to mention bronchoplasty, angioplasty, chest wall resections. Those are advanced minimal invasive procedures that we can do with a robotic platform, but probably not with the VATS, at least not in our hands. And the length of stay was 1 day shorter with robotic surgery. So how do we get patients through? It's great to do a minimum invasive surgery, but it's more than that. It's the whole perioperative period, and we have to start with that by setting expectations to patients. So we use an enhanced recover after surgery pathway that starts before surgery. Even when they first present to us, we already set the expectations with them. We do preoperative counseling about the pathway that they're going through. We do nutritional optimization, smoking cessation, optimization of the medical comorbidities. We can do all the pre-surgical testing while patients are undergoing neoadjuvant treatment. Pain control is essential, early mobilization, all with the goal to reduce complications, to avoid opioid use, and to get patients recovered faster. So this is kind of what that reflects. If you think about it, open surgery, the traditional chest surgery with a thoracotomy, patients were in the hospital for about a week. If you think about that surgery or the early robotic experience, if you read most studies, patients stay in the hospital with a median stay of about 3 to 4 days, maybe 5 days. And then robotic surgery with ERAS, and this is translatable to neoadjuvant therapy as well, it's 1 to 2 days. So it's not quite an ambulatory surgery, but this reflects how safe the surgery is and how fast we can get patients recovered. Because it does matter, patients may need additional treatment. So what are we doing post-operatively? When they go home, they should be continuing activity. They should have full activity level at discharge. We do set the expectations for patients. You're going to be more short of breath, you're going to be more tired, you're going to have less stamina, but this will improve as the lung is healing in about 6 weeks. Some patients may need oxygen, although we try to avoid that. And quality of life should resume or get back to baseline at about 3 months. So this is good. We can get patients through the surgery safely, but what about long-term prognosis? And again, this goes to the question of patient selection and how are we going to do it right to the patients? And we did some analysis on this using the National Cancer Database. Lymph node disease is a big prognostic factor in lung cancer. So we selected patients that this was the early chemoimmunotherapy experience, but that were treated for lymph node positive disease, either N1 or N2 disease, had neoadjuvant chemoimmunotherapy and then surgery. In the National Cancer Database, the lymph node downstaging, meaning the difference between the clinical stage and then when you actually remove the lymph nodes, how many end up being positive still. The downstaging with the clearance of lymph node disease was close to 2/3 of patients. That's major. It's a major downstaging. And if you look at the Kaplan-Meier curves on the bottom left, that's the clinical, separating the curves by clinical nodal stage. And there's differences, yes, but what really matters, what is the lymph node stage after treatment, when you actually remove it. And what you see is that patients that have N0, doesn't matter what their initial lymph node disease was, they're going to have an excellent prognosis. So this is really important, and this means that they're truly downstaged, that it's not just like, okay, well, we can detect it less in the lymph nodes. No, their overall survival is equivalent to having no nodal disease. And this was mentioned before, we have now long-term data over 5 years showing overall survival, and the most fascinating thing to me, overall survival is good, 65%, with in the Checkmate 816 study with nivolumab, no immunotherapy after surgery, so just the neoadjuvant. I should correct myself. Patients did get selectively neoadjuvant therapy, immunotherapy afterwards, but mainly neoadjuvant. What really stands out to me is 90% 5-year survival in patients that had a complete pathologic response. So this is essentially a cure. And this is unheard of in stage 2, stage 3 lung cancer. And the numbers we saw is, this is not a small subset of patients. This is every third or so patient. So really, really promising results. So that's why we're pushing for this type of treatment. The takeaways I would like to everybody to take away from this talk is that chemoimmunotherapy works. Chemoimmunotherapy in the neoadjuvant space for early stage lung cancer works. Robotic surgery helps us deal with the challenges that derive from the treatment effects in the lung, and it's safe. And our real-world experience is better than what is in the literature. We see higher rates of pathologic complete response, more minimal invasive surgery than you would expect from the data from the trials, fewer complications, short hospital stay, especially in combination with ERAS. And the prognosis is truly excellent, especially in patients that respond. I think there's still a lot of open questions, patients that progress, patients that don't respond, how we're going to incorporate additional treatments, and what does that mean for patients, and what have you. But from a surgical perspective, it's really been very great experience and very encouraging to have that close collaboration with medical oncology, radiation oncology, really having great treatment options now for these patients. So I'd like to thank everybody for your attention. I'm happy to take questions.
Any questions? Dr. Miller?
It was a great talk. You mentioned that your medical oncologists are competitive in choosing who they're going to put through. I'm curious, do you know, are they recommending certain patients over others based on molecular status, like PD-L1 expression, or are they kind of doing an all-comers approach?
Yeah, that's a great question. I think PD-L1 status is probably the most important factor that we're using. We're using some of the histology too. So, for example, mucinous adenocarcinoma, we've learned, it's just not responding all that well. Although it doesn't respond really well to anything, honestly. But yeah, those patients, depending on their presentation and how symptomatic they are and what have you, we may shy away from that. And then I think they're also learning a lot more about patients that may have toxicities from immunotherapy and trying to avoid that and really having selecting patients that we're expecting to do well with the treatment. So
you go straight to surgery in those patients then?
No, I mean, we're still discussing things in a multidisciplinary setting. We are always having the chemoradiation as a good alternative for patients. Yeah, it's really that multidisciplinary dialogue, trying to figure out what is the best thing for the patient.
Dr. Newart's outstanding talk, and thanks for sharing your experience. I think your observations mirror a lot of what we have experienced here. I'd like to hear your thoughts on the timing between completion or neoadjuvant chemoimmunotherapy and the performance of the surgery, whether or not you feel that is important. If it is, what kind of protocol do you guys have with respect to timing? And also with the lymph node status. So if a person has clinically or biopsy confirmation of either level N1 or N2 nodal positivity. I understand the post-resectional, what you see in terms of survival, but what are your observations intraoperatively, especially those hilar nodes like that level 10 near the truncus anterior? If that is proven positive before your surgery and they undergo immunotherapy treatment, do you have any kind of trends, any observations as it relates to trying to dissect out those lymph nodes?
Fantastic questions. And I don't know that I have all the answers here. There's a data-free zone. Timing, I think, will make a difference. I think that the longer you wait, the more fibrosis you get. But what is the right time? I don't know. I typically wait at least 2 weeks. Some surgeons wait 4 to 6 weeks just because it's the number we have in our heads. I don't know that there's a right number there. In the trials, usually the surgery was done a little bit more quicker than what we see in real life practice. A lot of times we see patients with the first scan after about 2 weeks because that's when typically the oncologist sees them back and they have their restaging CT scan. And then it'll take, typically in our practice, about 2 to 3 weeks to get them scheduled. So they end up somewhere around between 4 and 6 weeks. But we can probably, I think the trials called some of them about 3 weeks after, especially in the LCMC3, it was fine. I think it's safer to do it earlier. I do think that we're going to get more and more fibrosis, similar to radiation maybe, the longer we wait. How do we deal with lymph nodes? I think that there is data that there is some memory in lymph nodes in the mediastinum. So while we want to be radical in removing these lymph nodes to really make sure that maybe there's microscopic cancer and we still get it out in these fibrotic nodes, there's also the counter argument that says, okay, well, maybe the patient needs those lymph nodes to continue the immune memory that is persistent in those nodes. There's anecdotal evidence that maybe patients, with less lymph node dissection do better after neoadjuvant chemoimmunotherapy. I think it's an important topic. I don't think there's one answer for everybody. I do agree that the hilar lymph nodes inside the lung are the most challenging. So technically, I worry about those patients the most. In this video that I didn't show you all the way, it was very tricky to get around all the left upper lobe branches. It was all baked together. I like to get proximal control on these patients, and I think then we can do it safely. And I don't shy away from these operations, but I do respect it, and we want to be prepared. And again, we can do things like angioplasties, bronchoplasties, and things like that with the robotic surgery. So I think we're prepared to deal with it, but it is challenging.
Any other questions? Well, this was fantastic. Thank you, Dr. Nortz, and thank you, everybody, for your time and attention. It's a great session. Enjoy the rest of your day. We'll see everybody at the Crawfish Boil.